let's take it real soon. You know we got what you need, baby, so take it real long.
Design for AM. AM for artists. Visitor perspectives and cutting-edge products on the show floor. These are today's top stories on Formnext News. Live from the Frankfurt Fairgrounds, we bring you the latest updates and essential stories from the world of additive manufacturing. Design for AM is able to redefine manufacturing by combining engineering expertise with creativity. Yesterday's panel Design for Additive Manufacturing brought together experts who highlighted that AM is still a relatively new tool for designers, complementing traditional methods. Despite growing market maturity, many users and designers still lack training in key aspects like layer height, materials, and printer settings. However, significant developments are underway to accelerate the adoption of AM supported by new and innovative design approaches.
And the thing I'm most excited about is materials development. It's been amazing the amount of new materials being introduced every day in the additive space, and that's going to add a ton of design flexibility for people that heretofore may not have been able to make a structural component appropriately, or something that can deal with high temperatures and still be performant. And those materials are being developed every day. So that to me is incredibly exciting. I think unleashing the power of creativity for materials, the application of those materials, the design and simulation of those materials, I think that's an area that's we're going to see a lot of advancement, and therefore usage of AM in terms of design of end-use products.
Pseudo, the Hamburg-based artist duo, returns to Formnext this year with their impressive artworks, including the design of the Formnext Award trophies.
We are artists that are using 3D as a tool since a few years, and we love it. We fell in love and we deep dived into it, and now we are creating huge sculptures with our own 3D printers from our own workshop, and in collaboration with other 3D manufacturing agencies.
Known for their innovative creations, they use a variety of materials and techniques, merging aesthetics with concept.
Since we are artists, we always create concepts for series, and in combination with the 3D printing, it's always for us important that we have like a message that we transport through the art, and that's why the series, it's not only one piece, it's a series out of more pieces, and so we create a topic first, and depending on the topic, we create the 3D pieces.
At the AM Art Space, visitors can experience their immersive 3D printed sculptures. Yesterday at Formnext, EOS unveiled the P3 Next, a new solution for industrial polymer 3D printing. According to the company, this new end-to-end production platform delivers 50% higher productivity and 30% lower operating costs. And it features 80% material efficiency.
When increasing the productivity of the printing, you break down your individual process step and you accelerate all of them. You accelerate the recoding, you accelerate the heat up, and you accelerate the printing, the exposure itself. This is how you increase speed, and we have looked into every detail of that machine, accelerating it to the max to provide additional productivity, additional value to the market.
Boston Microfabrication has introduced 4 new materials for its MicroArc printers. Each of these materials enhances the versatile applications, especially benefiting manufacturers in the medical, electronics, and aerospace industries. Ermaxan Additive has introduced its Enavision 150 Dual, a metal laser powder bed fusion machine tailored for the dental industry. With dual 300W fiber lasers, it provides up to 50% faster production than single laser systems and can manufacture up to 250 dental crowns per cycle. The machine enables the creation of intricate, customized dental components.
I study data science, and I would say anyhow it's something which will be interesting also for me for my future career. I had these opportunities to really open my eyes to visit all different kind of industries, and also to really form which industry which I would be more interested to work on.
I'm here for new technologies. We are going in a very good wave now in Brazil because we are willing to learn about new technologies. And Germany in this show is the best place to learn about it. It is the hot spot for 3D printer and additive manufacture.
I am offering solution for the designers. The different sides of the industry, the different colors, the different texture and the different materials is really diverse in the solution, so yeah, it's quite interesting.
In AM you design first the holes and then the materials around the holes.
We wish you a successful day ahead at Formnext. Today, don't miss the key topic industrialization of AM at the industry stage with distinguished guests. Or if you're interested in building a 3D printed house, check out the BEAM Symposium at Portal House and the related showcase in Hall 11.
In my job, the slightest change of weight makes a difference. Thanks to additive manufacturing, we can switch out the heavier parts to their lighter counterparts. At Formnext, I get to work shoulder to shoulder with the AM community and push the boundaries of possibilities. Solutions presented at Formnext for materials or production systems become increasingly effective year by year. Another great question of using AM are the significant material savings. Simply put, AM celebrates sustainability.
Anki Interdentalis developed a 3D printed dental splint that uses a water-air mixture to remove plaque from interdental spaces. Designed from a patient's scan, it generates microdroplets that clean all interdental spaces in just 3 seconds, improving dental care for both professionals and patients. Fidentis offers a multi-material additive manufacturing solution for dental prostheses. Using the metal powder bed fusion process, it combines alloys such as cobalt chromium for strength and gold for precise fit. This robotic process ensures high quality, dense parts and enables efficient, precise production of dental restorations. Oryx Medicals is developing a 3D printed aortic valve for treating aortic stenosis. Unlike mechanical valves, it uses a minimally invasive TIVI procedure for easier implantation, tailored to each patient's anatomy. The valve combines durability with a longer lifespan, reducing recovery time and complications.
Riding a motorbike you restored yourself is a unique and defining experience. Every single part of the system is important, no matter how small it is. I support the AM community with this same passion by finding and creating the best materials for functioning production concepts.
Welcome to Formnext 2024 and welcome here to Industry Stage where we have our Formnext TV program just for you at home and for you guys here in the hall. This is our second day of Formnext TV live stream here from Hall 11 D72, and yesterday already was full packed with a lot of informations, with news. And we saw experts here on stage in product design who stated several advantages of AM, like 3D printing empowering designers and engineers to innovate faster. New customization options were stated, and with steadily growing print volumes, 3D printing will continue to revolutionize the approach, product design and manufacturing. That was the common opinion here on stage. The afternoon was full packed with new solutions from additive, with Pitch Next event. My colleague Sven was hosting that one. And but dear audience, what was your highlight? You can write it at the comment column in LinkedIn, where you see the live stream. And so we are very happy to get your questions and your comments there, so we can include them here on stage. Yeah, our team here produces a lot of live broadcast insights and reports for the visitors, for the exhibitors. So if you're interested in these, make sure to make contact to one of the Formnext officials. Yeah, today again you can expect a lot of interesting program around additive manufacturing experts and discussion panels here on stage. Today we will have industrialization as topics and figures from the AM market. So I would recommend that you zoom in the one or the other time today. Yeah, but now I think it's time that we have our morning coffee here. Before we start into the real business, it's really time to take a coffee, and I'm very pleased that I'm not alone in my coffee drink team here. So I'm very happy to have Rainer Lotz with me. He is President EMEA of Renishaw, exhibitor and chairman of Formnext Advisory Board. Rainer, good to have you here.
Good morning.
Markus Hering, he is VDMI Managing Director, Trade Association and Working Group Additive Manufacturing and honorary sponsor here at VDMA, is honorary sponsor of Formnext. And of course, I mentioned already Sven Krause, co-moderator here in our Formnext live stream. Yeah, Rainer, maybe a short review. What was your first day of trade fair yesterday? What is the mood at your booth?
Well, it's always obviously exciting to wait until the doors open, and then you wonder, okay, does anybody come through the door? And I can confirm many visitors came, so we had a good first day. And I would say overall, what changed over years now, you know, when we look over several years, what changed is you see more mature visitors around the technology. It's not so much anymore the people, they come and, oh, what is it, additive, what is it like, and is it a fancy technology, is it a good technology? No, you have mature visitors coming in, and thank God, many of them with a project. So they come with their parts, they come with a project. They said, okay, I need 1,000 parts of these per year. That's the size, that's the material. And this is the area in my manufacturing hall. And so we have very mature visitors with clear ideas where they want to invest in additive. And I would say that's a constant change, but that was visible on the first day. That was very positive.
Do they already know the shape and the design and the material? Are they so
absolutely. Some of them, they come with their CAD model, and you really look at the CAD model. You have all the details, the properties, the tolerances, and you can right away, actually on the booth, you can make a feasibility study and tell him, is it something useful or isn't it useful, you know, to print this part, and that's a very good development.
So that's a first big step into industrialization, what we have as topic today.
Absolutely. Know-how on both sides is important, and I think the industry was growing up. You know, in the period of the hype, there were a lot of promises, and not all of them fulfilled, unfortunately. But today, the industry is more careful and is grew up, but also on the customer side. And when you look at it, medical industries really grew up. aerospace always have been really experts in it already. And obviously, probably for the bad reasons, we see a lot of projects in the defense industry at the moment.
Now, I think we are going to talk about defense a bit later again, but I want to get you in. What was your highlight yesterday?
As he said, we have seen a lot of people. You know, VDMA booth is a little bit different. So we have a joint pavilion. This time, some more exhibitors as we had in the other shows. We have an area where we show some products. Usually, this year we decided to show products where additive manufacturing is an enabler. So these are just products from industrial production, what you just can produce with additive. There is no way with the classical technologies to do that. And I guess that is also important due to industrialization, that you show there are solutions what for you need additive technologies, and that is still available, that is mature, and that is used in industry. And we see, as each year we see an interest from the visitors about that, and then they can go directly to the exhibitors and talk with them about solutions, about technical offers, as he said, with their ideas, with their approach, what they have, and then they go there. So that is, for us, the show where we be here and why we are being here. We have not to sell anything. We try to get in contact with our members and try to show what is additive, what is the state of the art.
Yesterday, Sven and I, we already talked about your survey. You've done a very comprehensive survey, and so you can maybe share the one or the other figure or number about the mood in your community. When you say you brought more companies to the fair, that sounds like a quite good mood. They want to show what they can. They want to exhibit what their experiences are.
Yeah, we do this survey usually twice per year. So we have a spring survey and an autumn survey. Now we are speaking about the autumn survey and the results. What you mentioned. What we see, first of all, the industrial conditions and the economy globally is not in the best situation. We all know that. And therefore, if we compare this result with the others, we see it's not as positive as it has been all the other times.
So you're talking about the German markets especially?
Now we speak also about the international markets. Business expectations are lower. In the long-term perspective is still positive. So if we speak about in 2 years ahead, they are still positive and 80% believe it's growing. But in the shorter term, it's more moderate, I would say.
So let's talk about 1 second about the reasons. So we all are very happy, especially here at the exhibition, that there is the C word. Nobody wants to talk about the C word, Corona. So that is it a reason for a lack from these times that the companies still have problems? We just make some assumptions. What is with US, the change in government there? What is the problems we have in Germany with the new election date? Are these parts of the mood in your community?
I guess one issue is we have a lot of sectors what are now struggling, what have a real decrease. Automotive is one. And a lot of industries are depending on automotive.
So that is a structural problem with electromobility and with we talked already about China.
And additive is also supplying technology to mechanical engineering companies what are delivering to automotive. So automotive at all is not the main focus of additive, but the supply chain is part of it. And the supply chain has a lot of problems, and therefore we see I would say less business expectations for mechanical engineering at the moment. Mm-hmm. We have a global economy crisis. We have it in China, we have it in the US, we have it in Europe, especially in Germany. So all these things coming together. Rainer mentioned the 3 sectors where we expect growth. The market share of these 3 sectors are in additive higher than in classical mechanical engineering industries. So we have with medical, one sector where we have interesting approaches with additive. We have defense, what is interesting. And the third one is defense, medical, and
Aerospace.
aerospace. Where we, from beginning on, are able to deliver in.
Yeah.
So these three are growing. Therefore, we have the positive outlook. But at the moment, it's challenging. We expect for next year that the American market is growing. We expect in spring the economy will rapidly increase. That will have an influence in additive. But if we speak about that, we see another information what is really interesting. That is, we see China more and more as a competitor for additive. It's not anymore an interesting market.
All around the world, in Europe and in US, I think.
Yeah, and if we are looking back, we had 4 years ago, 5 years ago, we had major market was Europe and Germany, 80%, and then around about 20% on the same level, US and China as a supply market. And nowadays it's 10% and less China. US is coming in a dimension comparable to Europe, so more than 70% say US is for us an interesting market. And on the other way, if we're asking them, and we did, where are your main competitors coming from? That is now China in all sectors. So there is a switch. And if we go around at Formnext, you can see this.
Rainer, we talked about...
Yeah, there are obviously a combination of many factors if we look at the economy there. And certainly one last comment about the COVID crisis. We have a lot of company, they lost their reserves during this crisis. So there is an effect till today, especially in the large community of medium to small-sized businesses, that they lost their reserves. And normally, you know, if you get into a crisis and you have reserves, you have some anti-cyclic investments, you know, to develop new products and so on, which you benefit in the next growth period. And many companies couldn't do that anymore because they lost their reserve. So it's a different scenario today in the economic situations we have. And obviously, us Germans, we always think it's only us who have a crisis. Guess what? We're in good company. There are others, and we moan a bit more, I would say. But there are many other markets with difficulties, including China, you know, in some segments. But when we look at the US, we obviously, the year of election is never a great year for investment in capital equipment and so on, because everybody is careful who will be the next government, can I write it off, what are the taxes and so on. I think it was a good thing that we had a very clear result. That it's not for many months who is the next government, but there is a lot of uncertainty because we shouldn't forget we have now, it's clear who will be the next president, but it's unclear what kind of tariffs and stuff he will put on international trading. And this can also be a blockage in international trading, and it can be again a blockage in investment. So we don't know what's coming. So
it's right, but
I don't understand where the uncertainty comes from in a company because of a change in government. I have to know, as a company leader, I should know where to invest and where my customers lie, independent if the conservatives are winning or I don't know.
It's how much money do I have at what cost? Exactly. You know, it's relatively simple. Is my taxation much lower than it was before? I have more money in my pocket.
Are they waiting for subventions or what?
Yes, and just the tax rate as such will go down. But then it's also what does it do to the finance market to refinance my company? What is the interest rate on it? Then in inflation, what does the inflation do? You know, this is all important for companies where there are no reserves anymore and they actually have to finance growth in a way, and they want to know at what cost can I finance my growth? And so it is important who's in charge in the government, and it has an influence.
And what you said about the tax may be what are coming if we're delivering it 2 years. So that is an open question for us. Nobody knows how big it will be. And then the other question is, what will be the tax for all the others?
Yes.
Will it for Japan the same? China much more or not? So, and the situation is, especially in some sectors like additive, we have not so many competitors coming from US with the same technology. So they have to buy abroad. And if they put tax on it, it's for us. If the competitors are in the comparable situation, it's okay for us. And that means the customer has to invest more. But if he is getting some subsidies from government, maybe it's able for them to do so. So these are open questions, what we still not yet know, and we have to wait what are the next decisions from US government.
I think what we agree is that we're entering a very dynamic phase. And the simple question is, how ready are we, to cope with a very dynamic phase? And we, I mean us companies, I mean us in Germany, I mean us in EU, I mean us in the associations, because we have to respond much faster on all these changes Markus just described, and I'm not so sure how ready we're for that.
Sven, let me give you one question. I want to know, you had the Pitch Next event yesterday. How many Chinese or abroad companies pitched? So my question behind is, where do the new developments, the young companies come from? Is it the European area or US or China?
I will answer directly.
Okay.
Let me first do a quick comment on that, because I see two perspectives and just want to add that. I mean, you mentioned what is the role of the government. I see it very crucial, because if you don't know what to write off in the next year, and as you said, what about import duties and taxes, this is a big issue, especially with the US market right now, because they announced a lot, but you as a company, you don't know what exactly would happen. As you have no reserves, you have to plan how to do it. The second one, and this is what you brought in at the very beginning, Frank, was what about our level of industrialization? That's a trend I see with the companies I'm working with, and probably you, Markus, can agree, because you have all the industrial players as well in the VDMA. So the companies realize, despite any development governmental-wise, we need to improve our processes, we need to get faster, we need to streamline everything, and this is a heavy trend I see. And this is, in my opinion, the most positive trend we could see, because this is a positive outcome of a crisis. Not do much to do too much savings, not save you unhealthy, but on the other side, especially for startups, and that brings me back to the startup area. Arno and we mentioned yesterday, the water in the river is very low, so you see the obstacles. You need to navigate better, you need to plan better, you need to get through the river with lower resources. And this, in my opinion, is in an industry where you have like money endlessly in the past, it's very good that we have this situation, because it brings us better results. Getting back to your question regarding Chinese startups, there was not a single one. And I remember in all the last events I had, we had a tremendous amount of Chinese startups. Could have different reasons. One could be that it's no longer interesting for them to present here at the audience. I don't know, probably they have enough customers and resources elsewhere, and they just started when they're already a grown-up company. I think even they are much faster than our startups are. That's for sure. But still, the startups were promising, but you could hear in every second sentence and in their presence that it's more challenging than in the past. Let's put it that way. But I see it totally positive, I must admit. I mean, I'm just an external in this industry, but I see already so many positive, let's say, initiatives where you can see that the companies have definitely understood what is going on.
I would like to underline that, because if we go back, our successes over the last decades, it's all built on productivity, it's built on performance, and therefore we have to work on these factors again. We have to perform, we have to have good productivity, and this will increase our competitiveness. That's what we did in the past. We lived on the back of very good products and the successful companies, and there is no change in the future. There might be a little change in the competition, but we have to go back. We have to be competitive, and that's only if we're productive, if we're performing on a high level, and we can see that the performance of the solutions we see here, we can see the level of automation which is going there. We can, you have machines with a similar technology. They have 3-4 times the throughput now, and you can see that companies said, okay, I can moan about the political environment, but what can I do? I can get better. I can offer better, I can perform, I can be competitive, and that's what I can influence. And you can already see here, I fully agree with you, you can see solutions in companies, they said, well, put your arms up, let's do it. And that's a good thing.
But the challenge, what I see is with the competition coming from China, is we have an excellent basis in industries. We have an excellent quality, no doubt. But the speed, what is coming in development from China, that is a challenge for us. So if I see from
Dynamics,
from event to event what they developed in between, that is that time what we need for having an analysis about our situation. And that is, I believe, the biggest challenge what we have, to be more flexible, to speed up in decisions and in developments.
But Markus, I pretty much think the higher the pressure is, the faster we get. Because we got lazy in all the being rich and getting all this money. Don't get me wrong. I mean, I was on the same boat, yeah? So we got everything for free, basically, especially in the startup where I'm most in the startup area. So now it's more difficult. It's a lot more pressure. You need to get faster. But this is a very old saying, that the more pressure you get, the faster you get. So I'm pretty sure we will do it. I'm pretty convinced.
I want to bring in then another subject. You already mentioned defense, and there is an advantage you not mentioned of AM, the scalability. And so in defense we see with a political situation in Europe that there is a need of material throughout the complex, all the defense, I don't know, weapons, and I don't know, all the stuff. And so we need a lot more in a very fast time. We have the 100 million euros program in Germany, and I don't know how much money Spain or Great Britain, I don't know who invests. So my point is this may that be the knack for industry, because of the advantage of AM and scalability, that we can grow very much faster with AM solutions, that we have to invest now to scale up this sector?
I think, you know, defense is a very good business at the moment for the wrong reasons. You know, let me put it like this. And obviously AM technology is very suitable to the requirement in the defense, where you either need a particular functionality of your part in a particular material, or you need very fast a spare or some part, you know, where you cannot wait for a long supply chain. You might not always have stock in place. So there are many good reasons why to use AM around the defense industry, and we see growing part. But I also wouldn't want to forget that the volume of the business in the defense industry doesn't cover up for what we're losing in rather civil applications around this, around these conflicts
and
here.
It won't cover up in the next years and upcoming years, when every country in Europe should invest more millions and millions in this sector.
It's a time question. I work in the meantime heavily with some military organizations in Germany, and I can tell you just the timing of regulation and getting the commitment. It's not like working in the private sector where you probably have a bigger need and you need to solve it quickly. We and all the military organizations build up processes in the past that are quite long in their decision making. So it might cover.
But now should be the time to change that, right?
If we stick to the speed, my best guess is in Germany we'll get the level of ability to defend, which we had 1990, we'll get it probably in another 40 years or something like this. That's the speed we're talking about.
And last but not least, to be honest, defense has from beginning on one sector where additive delivered technology to. So it's not a new one, it's a growing one. Now we have a spotlight on it, so everybody's looking on it, but it always has been there as a business case.
Right, but my question was if it's now the time to be the knack to open and to make a push that the whole...
The growth is not in that dimension that you say it's, as Ryan said, it's not instead of automotive or others, it's growing not in that speed.
I would say the scale we'll see in medical industry is honestly far more interesting.
Yeah,
you know, the scale we're seeing there, so... Don't want to drag you now over to a positive topic in industry, but it's a fact that the way it scales up in medical is fantastic.
And that's, by the way, that's something you could see yesterday in the startups. Despite the challenges they have with regulations and the time of getting into market, the number of startups is increasing. And with excellent solution, much better solution than a few years ago. So yesterday was amazing what we had in medical solution, very practical ones, not the fancy always, but like the tooth cleaning or they are tissue printing. So those are really
good stuff
interesting issues that we need to cover in the future with the cost situation in our healthcare. So I think this is really a boost sector for sure.
Okay, so we see the growing path. Not everybody sees the same growing path. I understand, but the mood is there. We have to wait a little bit longer to see it in the books. But the mood is good, and I wish you three a very good next today for sure. But the next upcoming 3 days, a good Formnext and good businesses and. Good moderation. So, dear audience, that was our morning talk here from Hall 11 in D72. And I hope you zoom in when we have the next expert insights here on stage. See you later.
AM Craft is an EASA certified supplier from Latvia, specializing in polymer additive manufacturing. They provide 3D printed interior components for aerospace to solve supply chain issues, backed by a global production network that ensures timely deliveries. Their digital warehouse enables the instant reproduction, solving future challenges as they arise. AmSite revolutionizes quality management in industrial 3D printing, using its AI-powered software solution. By automating tasks and optimizing processes, AmSite reduces quality management costs by up to 70%. With its streamlined approach, it sets new industry standards for both efficiency and cost-effectiveness. Axolotl Bioscience created tissue print, a xeno-free bio-ink designed for 3D printing human tissue models. It ensures 90% cellular viability and works with a variety of delicate cells. Compatible with multiple bioprinters, tissue print saves time and reduces costs, offering a reliable and easy-to-use bioprinting solution. Microfactory specializes in resin-based SLA 3D printers with fully automated MSLA machines. These printers simplify printing, washing, and post-curing. They deliver precision, speed, and flexibility for dental models, audiology, and more. Cloud connectivity and scalable automation make production more efficient and reliable. Supernova Additive offers viscous lithography manufacturing technology capable of processing materials with viscosities up to 1 million CP. It enables cost-effective production of short and mid-sized batches without the need for costly molds. VLM unlocks new material properties for industries like automotive and aerospace, using both rigid composites and elastomers.
Step into the light, I'm alive, I can see your love shining. You put it on the inside, so no matter where the darkness, you been shining like lightning. I surrender, you fight my fight. Darkness ain't ever gonna take my life. I'm so give you my praise, that's right. I'm so give you my praise, that's right. I'm so give you my praise, that's right.
Consultant, I make sure to steer my clients towards personalized production to suit their specific wants and needs. My purpose, making not just serious production, but also making customization affordable, be it for prototypes, spare parts, or mass customization. This is where additive manufacturing gives you a competitive edge. When it comes to batch size 1, I have observed this very trend in several industries. This is what brings me to Formnext, my quest for industrially viable solutions.
Welcome to our Expert Insight presentations here in Hall 11 D72 at Formnext 2024. Today, our Expert Insights have been organized to dive deep into the focus of industrialization. We already had it here in our morning talks on stage, and our first presentation today is brought to you by Professor Dr. Jennifer Jones and Dr. Roman Bawinski. Professor Dr. Jennifer Jones, she's an interdisciplinary scholar working on several aspects of the additive manufacturing sector, including on resilient and sustainable supply chains and distributed manufacturing. I'm so happy to have you here. And Dr. Roman Bawinski, he's assistant professor in international business of University of Bristol. Roman is an expert in people's engagement with digital technologies within and beyond organizational boundaries. His current research focuses on the intersection of strategic leaders' decision-making and mergers and acquisitions. That's a time for mergers and acquisitions right now. Together they will present initial findings of an in-depth review of merger and acquisitions activities across the AM sector. And we're very happy to have you here and to put in the aspect mergers and acquisition together with the aspect of industrialization. And we are very happy to have you here, and the stage is yours.
Thank you very much. Good morning, everyone. It's a pleasure to be here again. I'm getting quite used to being on this stage every year. Normally I'm on my own, but today I've brought along my colleague from the University of Bristol Business School to talk to you about a project that we're working on together. And this is around merger and acquisitions in the AM sector. I'm quite conscious that I come here often and bring a business school perspective to a lot of aspects of AM, including around sustainability. But in this case, I wanted to take a closer look at the industrial change and dynamics that are happening in the sector. The bigger picture then, I think that it's typical when we're thinking about maturing industries to see levels of consolidation. We're used to having quite a lot of small specialist firms supporting us in industry, and as industry sectors mature, it is typical to see concentration through merger and acquisitions. What we intellectually are interested in is thinking about how that might be different at a particular moment in time. And at the moment, we feel like the dynamics of the contemporary global economy are changing to some degree some of the change dynamics we see across industry sectors. And I think that might be particularly acute when we look at additive manufacturing. So the global economy is witnessing a surge in nationalism, in protectionism and fragmentation. And this is likely to be exacerbated by the re-election of Trump as he favors more protectionist policies that then has a domino effect in the rest of the global economy. We also have other supply chain pressures that are impacting on the sector. This includes supply chain rupture and disruption due to factors like environmental interruptions, for example. Set alongside this, and this is where we would see maybe a point of difference in the contemporary economy, are politically driven strategies. And one of the reasons that we wanted to put together this project is to think more clearly and carefully about how that intersection of economy and politics helps drive each other, and the political narratives are having instrumental changes on all industry sectors. To the right-hand side of this slide, you'll see a case that I wanted to highlight that very much illustrates some of what we're talking about in this project. In September 2024, the UK government announced the acquisition of a semiconductor factory in the county of Durham. That's towards the northeast of England. It manufactures gallium arsenide semiconductors, and those are for military applications. The company was about to go bust, so the UK government has taken the very unusual step of acquiring this facility. And there's a very good reason for this. And it was the UK Defence Secretary who said semiconductors at the forefront of the technology we rely upon today and will be crucial in securing our military's capabilities for tomorrow. This acquisition is a clear signal that our government will back British defence production, will protect and grow our UK defence supply chain, supporting jobs and safeguarding crucial tech for our armed forces and boosting our national security. Now, this is a step change in the way that the UK government is talking about how it manufactures and where it sources the things, the critical assets it needs. Is, of course, an emphasis on the importance of defence, but I wanted to use this case study to really highlight for us these changing narratives that are coming from the political domain about the national economy. We know we have links to global supply chains, but the importance of being able to access things, critical resources and technologies within national boundaries, which is a change. So thinking then about consolidation in the AM sector, it is currently going through a new phase of consolidation. We have some of our initial data that Roman will talk to you about, showing the waves out of the change over time in terms of acquisition. So this has created the emergence of new global structures and a concentration of ownership. So on one level, we can track that and find some interesting observations, but part of our project is also thinking through some of the implications of this. If, for example, particular countries come to not dominate the manufacture of 3D printing machines, what might that mean for producers in other countries in terms of accessing that technology? We hear quite a lot of what I call chatter conversations around when I talk to those I know and beyond my own networks around what's happening in terms of consolidation. What we wanted to do to offer to the industry is to track some of this in a systematic way. I also raising this point about how do we access these resources, thinking about whether it may make some kind of hierarchy in terms of geopolitics and in terms of who our allies are, in terms of how and why we source the technologies we need. That might also have implications for time, for example, in terms of how we get the technologies and how they're delivered to us, and whether regulatory and trade barriers might prohibit some of this access. So then, our project at Bristol, I've summarised in some parts, but it's only a one-year project. It's first time we're working together, and it's going very well, I can say. And our key question really is how have these mergers and acquisitions reshaped the geographies and power relations within the 3D printing sector globally? Is this ongoing consolidation leading to the formation of hierarchies of access that could restrict access to critical technologies and components? I mean, there's a broader question for me that is around whether distributed manufacturing might be a way through some of these issues. But now, I'd with pleasure like to hand over to Roman, who's going to talk through. We would like to say at this point that this is the initial analysis of our data. There will be more coming, and we will come back next year with the more in-depth analysis as well. Thank you.
Okay, thank you, Jennifer. Welcome everybody from my side, or hallo und willkommen. So, as Jennifer has announced, we've had this project looking into what the consolidation looks like in the A&M market. And what we've done as a first initial step is look at 3D printer manufacturers to see what is going on there. And just to bring you some recent acquisition examples that we've seen. So we've seen back in 2020, Stratasys is acquiring Origin. Then we've seen Desktop Middle acquiring or acquiring Envision Tech for 300 million. So we've seen this wave of more and more acquisitions, and Nano Dimension is buying Global Inkjet. Nikon is also getting in, buying SLM Solutions. We're seeing Nexa 3D buying XYZ Printing, the SLS technology. And very recently, we've seen 2 announced acquisitions of Nano Dimension. So first of all, they've announced the acquisition of Desktop Metal, and then they've announced the acquisition of Markforged. Both of these deals have been announced, but they've not been seen through. We're going to expect them to come through either in this quarter or in the next quarter, starting 2025. And what is interesting here is before Nano Dimension has been taking over Desktop Metal, we've seen a lot of announcements and merger talk also between Nano Dimension trying to take over Stratasys trying to take over Desktop Metal for a bid for 1.2 billion. Now they've made the deal with Nano Dimensions for 120 million, so 10% of the original value. So there's a lot of dynamics in the markets. We've seen talks between 3D Systems and Stratasys about merging. So we're seeing this consolidation everywhere. A lot of the big players coming together talking. So a lot of dynamics. And what our aim was to sort of understand what is going on here. So first of all, we took a look at what does the consolidation look at? How many deals have we seen in the last sort of 20 years? And so as you can see in this slide here, the number has been growing since 2010, peaking in 2021, where we've seen a lot of the major deals, and right now it looks like we're going to reach a stable plateau. So we've seen 9 deals already in this year. So we can clearly see a market consolidation. And what we're then interested in is which are the biggest acquirers, because we're interested in the geographies, who is actually buying in the market. And what we're seeing here, that we see 3D Systems is the biggest acquirer with 10 acquisitions over this time period. Stratasys second business, Nano Dimensions coming in lately, as I've shown, quite a few deals, player from Israel taking up a lot of the market, even buying Desktop Metal from the US. But what I really want to highlight here is that we're seeing all of these firms are in the US based or in Israel based, so the biggest player making the biggest acquisitions, they're sort of all from 2 specific countries, taking over large shares of the market. So what we then looked at next is a country overview of which firms from which countries have been sold. And what we see here is that the biggest chunk, or almost 50%, is coming from the US and Germany, with a big variety of other countries involved there, almost 25%. But when we look at who's actually buying, where are the buying countries coming from, we're seeing that the US is almost 50% of the buyers. So 50% of 3D printing manufacturers that have been bought from US-based companies. And the big sellers like Germany or the UK, which I want to highlight here because we are coming from the British Academy, we have a British perspective here, they're selling a lot, but they're not buying as much. And I want to dig a bit deeper into this. So when we think about this in terms of inflow of ownership of 3D printing manufacturing firms and outflow of them, we can see that the US is gaining, so more and more companies are located in the US, whereas countries like the UK, Germany are seeing serious outflows. I'm going to highlight this in a bit more detail here. So the US is gaining inflows, whereas Germany is losing almost 10 manufacturers that have been bought by other countries. The UK has sold 5, bought 1, so currently we have only 2 remaining manufacturers in the UK system. Whereas Israel is fairly stable, China also, but China is also quite a big black box on this one. So we've been struggling to find information about what is really going on in China. So this is something that we want to get in next. And then what we did next is sort of to map out where do we see like the majorities of 3D printing manufacturers. And what we can see here is that the biggest bulk, so the darker the color, the more 3D printer manufacturers we see in these countries. And what we're seeing here is that the US, and I didn't put the numbers, but it's about 43% of manufacturers are currently located in the US. The numbers in Europe they're fairly stable within the EU, but what we're seeing is that in the UK, the numbers are dropping. So we only have these 2 manufacturers. One of them, Renishaw, is industrial. So if we're thinking about the narrative that we heard in the beginning about these becoming defense critical, and if we want to have sort of access to 3D printers as something that's very relevant for our supply chains, thinking from a UK perspective, there might only be one manufacturer, and they have been on the market, they were trying to sell, so this might become critical. As we can see in the map, I don't think you can see it highlighted here, but Israel is also becoming one of the big players. So we're seeing a centralization of power within the 3D printer market within the US and within Israel. And for us now, moving on from this, the next steps that we're going to take, or that we want to take, is really reach out to affected parties, to involved parties. So we would like to talk to you, to additive manufacturers, if you're suppliers, if you're customers. Is this something that you're worried about? Is this something that you're thinking about? Where will I be able to buy a 3D printing manufacturer? Where will I be able to get spare parts for this? Where will I be able to get materials? Is this something that is on your agenda? So if you would like to speak to us, we're always very keen to learn about your industry's perspective. This is like a high flyover level. And the next step that we also want to do is we want to extend the sample. We want to see what is happening beyond sort of the manufacturers. We want to see what's happening at the materials level, because materials can also become critical in the process of sort of supply chain. We also want to get your input or understand what's happening in post-production or in 3D printing services. So what we're trying to do next is move beyond what is happening with just the 3D printing manufacturers to see what is happening in the supply chain, if we can see any bottlenecks, if we can really see that there are going to be hierarchies of access where coming from one country, we might not be able to get materials or access to spare parts or to printers at all. And this, from our perspective, might be especially relevant when we're thinking about industries such as national defense. So then, sort of closing is, I would like, as this is a research project, to reach out to you, to ask if you want to get involved with this, if you want to have a conversation with us. We are really curious to learn what the industry side, what you are thinking about these measures. So really, reach out to us, chat with us. I think this is a really, really interesting time to start thinking about what does national or global politics and sort of this consolidation, how do they work together, and how will they be affecting companies or the additive manufacturing sector in general. Okay, and I am done early, or we are done early, so thank you very much for your attention, and I'd really appreciate if you would reach out.
Yeah, a round of applause for these two.
We were.
Thank you very much for your presentation. Yeah, how does the centralization has effect on the user base? What is the effect? Is it a growing cost for materials and machines, or what do you expect?
I think when we think about different operations of manufacturing systems globally, I think that there's different pressures to change those manufacturing systems. So we do have highly centralized kind of global factories, if you like, in the global economy. But I think there's pressures to decentralize or have distributed models, in which case material supplies become really important. So I think the materials flows can be really important in this narrative in terms of where you can access those. But material resources, of course, are often fixed or in a small number of factories.
So I have to secure that I have a supply chain of the material I need when I start in a bigger project, for example.
Yeah.
So that's not as easy as in the past.
Yeah.
Although there are coming up new materials and the business is growing and the market is growing, that could be a problem
particularly with new materials, because of course they may be owned by one firm, for example, before they become broader. Yes.
I see. And this morning we had the discussion about China. One colleague said he sees a very much growing business, AM business in China, with more mature machines coming to Europe. Europe to try to be sold here. Is it the same? You saw China was not as much dark highlighted as US, so there is a real big gap between these two.
There's a
still?
big information gap. So in terms of academics accessing data, there's a difficulty accessing data from China.
So the true data could be much more than you have access.
It's a big problem, yes.
Yeah.
Okay.
Exactly. I tried to highlight this, that China and get access, but it is hard to come by because it's not as readily available as a lot of the Western data is.
Which is why we do the shout out to come and speak to people, because the data only tells you so much, doesn't it? And then you need to find out the rest of the story.
I hope our viewers via LinkedIn stream, they will follow and have a lot of comments. I just checked, there were no comment I could see. But let me look into the future with you two. The re-election of Donald Trump, and he promised to strengthen the US economy. There could be much more money in the market there to enhance merger and acquisitions even more. Do you expect that, or do you expect that we are over the hill?
I think there's some question marks around. We know what Trump's intentions are of making America great and what mechanisms he intends to use to do that, and they can be things like trade tariffs and also boosting domestic industry. But we have his first presidency and we have data around that, and some of the initial analysis of that data is that some of his mechanisms to increase domestic production by mandating some companies had to have 20% US suppliers had the opposite of the intended effect and made America more reliant on global supply chains. So I think sometimes when you try and tinker with the global economy, it doesn't quite produce what you intended it to do so. But the bigger picture is still around national economies and thinking about national security. So I think that operates independent of Trump in a world that is more geopolitically unstable. I mean, we're looking at the UK, so of course there's dimensions around Brexit, so that's again complicating this picture, but a refocus on the national where we're used to thinking about EU level or regional or allies. I think it's, rethinking the national economy essentially.
And when you're talking to the community members, are they stating that they need a national program in Europe, in UK as well, or do they rely on their own strengths?
I think if you speak to somebody from the UK and you ask them about our industrial strategy, everyone will groan and moan and say, where is it? And we do have one now, but it looks very much like an old version of an industrial strategy. So I think we would look with some envy, particularly at Germany and thinking around Germany and EU strategies, looking at envy to the US even in terms of having strategies. So I think maybe it depends where you are, but I think most people would think that if there's strategic importance in particular sectors, the government needs to have at least an opinion on how they should be supported, and I think that will come.
Okay, thank you very much. Let me have one last question as a personal view. Had you already had the chance to go around and look at some booths or something, or did you arrive just this morning?
Just this morning.
Just this morning, and you had the chance
morning.
to look around. And what was very impressive in your opinion? What was a product or a presentation you said, okay, you have to, for our audience, you have to watch this one?
I only arrived this morning, so I couldn't tell you that yet.
So you arrived too this morning.
Very much delayed out of UK, the flight
Yeah.
yesterday.
So then, I wish you a good time here and a little bit of time to walk around the halls and to get your impressions, and maybe you bring something home you never expected.
Yeah, we're both here still for the rest of the conference, so if you see us, please come and chat.
Yeah, perfect. So, and make sure to check our live stream, because there might be the one or the other comment to get in touch with you, because, you know, we are streaming all this on LinkedIn live stream, and there you can have your comments and see and make contact to these both. Thank you very much for having you.
Thank you.
And have a good time.
Thank you very much for having us.
Thank you. Goodbye. Yeah, ladies and gentlemen, After a short break, a short commercial break, we will see some highlights there and a lot of pictures from the exhibition ground. We will have the next highlight here on stage as well. Peter Körte, he's a very new member of Siemens Managing Board. He will be with us and he will be sharing his views of his strategy and the Siemens strategy, especially in AM. And we are very curious about these and make sure to zoom in then.
Baker Hughes is using additive manufacturing to reduce the environmental impact of gas turbines. By replacing casting methods with LPBF technology, they improve efficiency, reduce CO2 emissions by 38%, and support their goal of achieving net zero emissions by 2050. Ceratizit developed an additive manufacturing process for cemented carbides used in cutting tools and wear parts. Their FFF process reduces CO2 emissions by over 95%, allowing for inner hollow structures. With 100% renewable energy and reprocessed materials, Ceratizit leads sustainable manufacturing. Stratasys promotes sustainable luxury footwear by reducing emissions, conserving resources, and lowering costs. A recent study shows that 3D printing reduces emissions by 25%, material usage by 49.9%, and even electricity consumption by 64.3%. The J850 textile is highlighting additive manufacturing's sustainability potential.
The skate park's an important part of my life. I enjoy the thrill of the next trick, testing my own limits, and pushing myself beyond my comfort zone. But it only works if I can rely on my board 100%. Creating reliability and safety in an industry that also pushes limits is a meaningful part of my role in the AM community.
The whole world is talking about the need to rebuild supply chains. But many of my human colleagues overlook the fact that conventional manufacturing technology won't cut it. Distributed manufacturing needs a digital manufacturing method, like 3D printing. So me and my colleagues are an important part of the AM community.
Step into the light, I'm alive, I can see your love shining. You put it on the inside, so no matter where the darkness, you been shining like lightning. I surrender, you fight my fight. Darkness ain't ever gonna take my life. I'm so give you my praise, that's right. 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 I'm so give you my praise, that's right.
Welcome back to our next session here at Formnext 2024, here at the industry stage. I'm very happy that you zoomed in to our next highlight. Today we have a new format for you and a new highlight guest for you. He just joined the managing board of Siemens AG, has a long experience as the company's chief strategist. He works on building an ecosystem of partners and customers and academia to address the global challenges. His key focus lies on digital transformation for companies. Who better could be here today with us than Peter Körte. I'm very happy to have you here. It's a pleasure. Peter Körte is CSO, CTO of Siemens AG. Peter, first of all, congrats to your new position. How does it feel to be a new boss of a 70 billion plus euro company? How does it feel?
It feels great, simply because if you think about technology, it's evolving even faster. So it's not just the digital realm. Everybody talks about AI and so on, but it's also what's happening in the hardware and the combination of hardware and software. So I think it's the golden age of technology. So I think the timing is just perfect. I love it.
So there are so many employees looking up to you. Don't you feel the pressure on the tasks ahead?
No, it's as long as you can give clear directions, because the world becomes a little bit more complex, as we know. So we get a lot of crises around the world. We got, of course, hyper competition coming from China. We got over-regulation in Europe. We got potentially new tariffs in the United States. So the world becomes complex. And there's not simple solutions. So people usually look at you and say, you know what, give me a simple solution. Unfortunately, there's none, but we can work on it to solve these problems that are coming our way. And I always believe that technology, if used by the right people, will make a difference.
Okay, you walked around this morning. You had some time. You are a very busy person. That's a reason why we are happy to have you here. But when you walked around Formnext, what were your impressions? What did you experience? What was your task to go around?
Well, my number one question to everyone was, where are we in the maturity of course, additive manufacturing? Are we still in this long journey where initially we said, well, this is for rapid prototyping, this is just for one-offs? Or are we already, have we crossed the chasm to say it's really fully industrialized and we're there yet? And I have to say, I'm really impressed. I saw great examples. Of course, you always see these wonderful pieces, one-offs that are super high-tech that you use in particular aerospace defense. I mean, think about all the space, all the nozzles for the rockets. These are great examples. And they're going to stay, and they're here to stay. But if we really want to grow the industry, we have to industrialize it. We have to make it simple. We have to make it at cost. We have to make it at quality. And I've seen great examples. And so I am very impressed and I'm very encouraged so far about where additive is going.
And where is the maturity of Siemens, talking about AM? I know Siemens has invested since some years into AM, but where do you feel your own business and what maturity level?
Sure. There you have to differentiate between, number one, Siemens is a user of AM, so we got 249 3D printers ourselves, which we use extensively for all kinds of applications. For example, for trains, so that you don't have to have a lot of stock. So we can produce them, on order, so that you build to order and reduce inventory, which is fantastic. We have what we call internally an additive manufacturing network, where we can also then ship orders, move orders around the world, depending on where it is needed, Australia or Asia, and then Europe and the United States. So we use it a lot. So therefore, I'm always curious to see where's the next frontier, where we can do that. But then also for our customers, of course, which is most important. What we believe in is to bring the two worlds together from the design. So early on, really thinking about how can you design for additive manufacturing. And then, that's the dream, after all, push the button and then you get it down to the control, to, of course, the automation equipment. And then you can manufacture that part with no any chasms in between for data and so on. So that's what we provide.
So what do you think in the future would be the biggest part of the business for Siemens, talking about AM? because you have so a broad product range and not only products but service solutions. So where do you focus, or do you hope to? Do you try to get everything up, but maybe you focus more on the software side?
It is what we say. AM is, to us, it's not a technology, but it's first and foremost it's a mindset, right? Because if you
don't earn money with mindset.
No, but what I'm trying to get is with the mindset is you have to think holistically. If you only optimize the piece on the machine, that's fine, but it's not going to get us scale additive manufacturing. What we have to make sure is that already the designer, as you build and design the piece and the part, you already have additive in mind, that you actually understand of what is needed. So it takes the two of them. It takes the design, the engineering side of things, and it takes the manufacturing of things. So that's where what we call digital threads, they span from engineering all the way to manufacturing. So it's really both. And we believe you have to have both, otherwise we will not scale the technology, because the technology has to become simple and easy to use. And if you only focus on one piece, it's not going to work.
And that is a business model for you, because the users should come to Siemens. I want to understand where you focus on earning money. So the users should come to you and have easy access to the engineering and to the design part, right?
It is. So first and foremost, we equip all the machine builders, right, that are here. So for example, with SLM, Nikon SLM, we work very closely together with all the major manufacturers, the OEMs. We provide, of course, the controls, but also we provide the software for designing, designing the work pieces that are eventually being built. So it is where these two worlds come together, and to make them successful so that their customers can produce faster, more resilient, more sustainable.
And can it be a business model for you as well to provide the software designs as well on a platform for an international growing business, that you are the data wrangler in the middle of the business?
We always have the debate. However, it turns out that when it comes down to the design data is something very proprietary.
That's the center, isn't it?
That is central. I mean, that's for most engineers. They would argue, my design data has to stay with me, and I will not share that with anybody, because that's my IP, right? Sometimes patented, sometimes it's not. But sharing design data is extraordinarily hard. However, what you're getting at is libraries. So if I have a library where you can start already with parts that are pre-designed, that's great. And this gets us into the conversation about AI, generative AI. For example, with Siemens NX, you have a couple of generative design features where you can tell the system, if you want to build an end effector for a cobot, let's say a gripper for a battery, then you can say, build it for me with these dimensions, with this weight, and then actually the system starts to design the piece. And why am I telling this? Because the design of that very, very end effector looks like an alien. It looks definitely not very symmetrical, because it's optimized. It's optimized by whatever you choose. Usually it's strength and durability and weight. And so these pieces, very often then you have to do 3D printing. Yeah? So you have to 3D print, because the value is not so much the cost, but actually the value is the functional properties, in this case weight. And you can reduce weight up to 80-90%. Reduce the CO2, because you need to have less energy with the cobots manipulating. And all of this, as you can tell, this really comes together.
Yeah, and that will be what part of the Siemens business you are running. So I want to know how big will the AM business be in your job as a strategist? You have a lot of. I didn't tell all the responsibilities you had because time is running fast. So is AM one of the others, or do you expect it so much growing that it will be your most important part?
So the way we think about this is we have what we call 11 core technologies, and it is one of the 11 next to the usual suspects of AI and data, of digital twins, of connectivity and edge and these pieces.
And they all
they're all
together.
connected. They all eventually are all connected because they draw off from each other, right? As I said, with AI, if you can create better design, that's actually also a good thing for additive manufacturing. So we really look at it from that way. However, I shall say also, it's not just about technology, it's what we see right now with sustainability coming, with all the regulations coming, and the requirements for material and reuse of material. This gets a big boost. So it's not just driven out of technology and digitalization, it's also driven by outcomes, by of course, improving your footprint.
Let's have a look at the overall market. Siemens will not invest in a market. What you expect in the next 5 years will not grow. Which figures, which data can you share in the overall markets? And could you divide it a little bit? We this morning talked a lot about looking at US, looking at Europe, looking at China, and we have the partner country. I wanted to come at the end, but maybe you can add the Australia as partner country as well, because you're responsible for EMEA as well.
Right. So we believe that the market today for additive manufacturing is about 15 billion, 1.5. Growing at 15 to 20%. So that means that by 2030, this market could be a 40 billion market, which is very sizable. And if you look around in bigger nowadays, 15 to 20%, you don't find that often. So it is actually one of the fastest growing or faster growing markets that we see. Yeah. Second, it is really evenly distributed across all major geographies. So Asia is third, Europe is third, United States is third.
And will stay so?
We shall see. We don't know. But the nice thing about actually additive manufacturing is about the resiliency that comes with it. So I'll give you an example. This was fascinating. We were sitting together with a furniture manufacturer. Yeah? These furnitures, not sure where they're coming from, Vietnam or China, I don't know. But the point though is with 3D manufacturing, you don't need to ship them anymore. Because if you have your microfactories, all what you have is your powder in the beginning, and then you print them based on energy, yeah, and all the intellectual property that goes into it. But what I'm trying to get at is, you can produce it literally anywhere, and you don't care about tariffs, you don't care about broken supply chains, you don't care about inventories, because, you know, this is selling this season, but next season it doesn't, so you don't have to host hundreds or thousands of them. So what I'm trying to get is, with 3D printing, you eliminate all of this, right? So it's really resiliency of supply chains that is fascinating, and that is also, because you mentioned Australia, think about in Australia, but we have a lot, there's a lot of energy. It's actually geographically quite, you know, separated. But 3D printing can bring a lot of industry also to Australia. So therefore, I think it's a great
But that fits for all markets, for all the world. I wanted to get to the point where US Siemens might invest a little bit more, or where our audience can learn, you should look at this market or that market, or maybe we think about moving out, or not maybe too fast, but we don't want to invest in this or that market. That was the point I wanted to get to, because as a global company, you always have to look, okay, you have just one money, as my mother used to say, and where to spend the one money.
It's true. So we just announced a big acquisition we want to make, or we signed. That is Altair. They're here too, by the way. And what Altair is doing is they provide a lot of simulation methodologies, in particular for electromagnetic and nonlinear designs on simulations. Yeah? And so they are a perfect match to what we today provide as a very comprehensive digital twin, because after all, the idea is we design and simulate everything in the digital world. We optimize it many, many times. But once we think this is perfect, then we still have to bring it in the real world. So, and there we need to have the manufacturing technologies, and additive is one of them. And turns out, Altair has very, very strong portfolio also for designing for additive manufacturing. So this is a great example where we invested, where we're investing a lot. But I shall say that this is us as a supplier to this industry. The interesting thing is, for this industry, for additive, where are the future growth markets? And there's always a big chasm. The chasm is that you get away from these one-offs, what I said in the beginning, but really you start to scale and see this in line production. And I get this as CTO, I get this since 4 years. Always the question is, when will we see additive manufacturing become industrialized? And there we see, of course, the usual suspects such as medical equipment, aerospace defense, energy applications. Think about gas turbines, making them, burn hydrogen. These are the usual suspects everybody knows. But there's new ones coming. And the new ones are actually the ones that really scale. For example, I just saw a great example for car manufacturer where, you have these seat brackets in the car. This is a pretty basic, boring piece of metal that you would think you would never do 3D
Don't
printing
say
on. That's right. But in this case, it is, if you compare it to a nozzle of a rocket, it is a pretty boring piece.
I got it.
Always depends on how you compare. And turns out, in the meanwhile, we can do this much cheaper and faster with all the benefits that I mentioned. But the key point is cheaper with 3D manufacturing. So we see now applications emerging in automotive. We see applications emerging in phones. I just was with one manufacturer who showed the hinges, which are produced. They produced 4 million parts in 4 months, and they all go into your phones as you hold them. Yeah, so that's massive. And then you see all the bikes, right? So all of that starts to scale, and I certainly believe additive is more and more crossing that chasm to scale up industry by industry by industry. So we see it coming.
Scalability is the buzzword for me. This morning we discussed which industry sector will grow most in future, and I stated, okay, it could be defense, and the both guys here on stage said, oh, don't compare it to medicine. Medicine will be much more business in future. And my point was the scalability in defense is a crucial factor speaking for AM right now. What's your opinion on that one?
Very much so. So what we see is, unfortunately, the trend around the world, everybody is investing into defense, Germany included. And in Germany, because this is very often it's a very German conversation, we have this very ambiguous feeling about defense. Defense is absolutely important. It's crucial for our security. Every country is like that. And so every country is investing massively into defense, as is Australia, as is the United States, as is Europe, and we have this conversation with the Ukraine war. And defense is perfect for additive. Why? You have a lot of high strength durability applications. They're usually not super high scale. They're usually required resilience of supply chains, so you can produce them locally. And then lastly, you have to have the ability to manufacture that over the entire life cycle of whatever you produce. Yeah? And that means usually hopefully, this equipment is out there 20, 30 years, however it breaks. So you have to, have spare parts and all of that. 3D manufacturing is perfect. It's just perfect for defense industry.
Can you add numbers or expectations about that market? What in terms of growing numbers?
I don't have them. But for sure, it is
not easy to say because it's so special.
For 3D manufacturing, for sure, it's special. Yeah. On a global scale, I would have to look it up.
Let's have a look at some very special applications in additive, like bioprinting, for example. There are some researchers who want in future print organs and tissue and something like that. Are you investing in this area as well?
So we don't, because we don't build the machine.
It's not your core business because you have Siemens Healthcare.
Exactly.
Well, would be their business, or would it be your business?
No, so what I'm trying to get is so if you wanted, and by the way, printing is not just for organs and tissues. So in particular, food supply is very interesting, right? So you could print your steak. Yeah, and in Singapore we do. It's just very expensive. And the question is, how can you drastically lower cost? I think it's going to follow a little bit. The use cases usually are more in industry right now, but eventually...
It's a very future-oriented.
It's a very future one. So we don't, as Siemens, and also not as Healthineers, but I let Healthineers speak for themselves, but we don't invest into that part. But we invest into digital twins. And digital twins, like what I said, with nonlinear simulations, skin is a very nonlinear thing. Yeah? You can actually, it's very elastic until it rips and breaks. And so again, with Altair, we are now able to do these nonlinear simulations. So theoretically and practically, we can simulate humans too, right? And we do this already. We can do this for cartilages, bones, Healthineers does it now for the heart. So the idea after all is, yes, to have a simulation of the digital twin of the human. And then, of course, the next step as an industry would be to manufacture these pieces too.
Everything most of what we are talking about is or is not possible without partners. And you mentioned you walked around, and I think I heard on your program we're visiting some partners, and I read about that you have a new partnership with Stratasys, and it's all about Navigator. Just give us some sentence about what is the core of this cooperation, and are you open for other companies? Are you open here for contacts from our audience?
Yeah. So as I say, additive manufacturing is getting now into a stage of industrialization. And what that means is usually you reduce the variability, and there is emerging a clear trend of what the best practices are, right? If you allow me to digress, and then I come back to your question. If you go back 100 years from today, there were more than 150 car manufacturers. Today, there's just a few. And at the time, it was huge variability. It was everybody doing their own thing, fully integrated. There were no standard procedures available because everybody had to learn this new technology called the car at the time. Today, we produce 90 million cars every year, and it's super specialized. You have everybody's supplier, and so on. In a way, this is what you see around here too. Yeah, it is that industrialization where you see a lot of variation, and it's really hardcore Darwin. It is variation and then it's selection. And we are in this selection state now, where we're going to see those who survive, and they scale, and not only do they scale in volume, but they scale in processes. And what we want to help with is with the MI Navigator, so the additive manufacturing industrialization navigator, is in a partnership with EOS, with Stratasys, with HP, with many others, to help manufacturers that want to do 3D manufacturing to really industrialize it. And so we have built a maturity model in there, which guides you from a scale from 1 to 5, and you can really say, how am I with my design? How am I my processes? How am I my quality? How am I with my people?
That's a fact for the companies joining you, or is it possible for users and for all the companies watching us?
So, twofold, one of which is together with the companies I mentioned. Of course, we standardize these processes, and then for all the users, this is an offer to use it.
That was the point I wanted to get to. It's not a closed shop. It's not
absolutely the opposite.
It's not your 5 will have a bright future. No. I saw it's like an offer for the community, right?
It is an offer for the community. The more, the merrier. Again, it is really making that precious knowledge available widespread, so that we can make everybody, scale up faster, industrialize faster.
And do you already have for every aspect you need in this community? Do you have for every place you need a company, or are you still looking for? Because now we have a broad stage here. You could announce what you need still.
So far, we're good. I'd say the first step, but yet again, if you are happy to join that, this is the key insight in the digitalization space is ecosystems need to be open so that everybody can contribute but also benefit from. And we are more than happy to have these conversations as you listen to this too.
Okay, so that offer is clear, I think. Last question, a short answer. Do you already have a small 3D printer, your private hobby workshop?
I don't, but we have a makerspace, and once in a while.
At home?
No.
Then it doesn't count.
Oh, okay, no.
Just at home in your private workers.
No, today, since I just moved, I don't. But I definitely would need one, because very often I have these plastic pieces that break, and I would love to have a 3D printer at home.
It's the same with me. Yeah. So we take some time after our session, go around and find one for our private working shop at home. So thank you very much for having you're with us and for your time spending here on stage. Dear audience, that was our highlight interview this morning for you. If you want to look at our interview because you joined in lately, then you can have access at LinkedIn page, and there you might have the one or the other comment, or you want to get in connection with Peter and his colleagues. So the next highlight here on stage will be our AM panel, Science and Research as an Enabler for Industrialization, and I hope you will zoom in then. And now I want to have a last big applause for Mr. Carter here on our stage. Thank you very much.
Thank you, Frank. Thank you.
The ILAK and ISW Institutes created the Marinaressa Coral Tree, a lightweight concrete structure showcased at the Venice Architecture Biennale. Using 3D printing for recyclable, water-soluble sand formwork, it saves 60% material use with no waste, supporting sustainable construction and decarbonization. Quorum Orthopedics developed the Quattro, a revolutionary prosthetic socket that offers enhanced comfort and adjustability. Using MJF printing, it features customizable volume and modular structure, making it easy to fit even with swollen limbs. It's a sustainable solution transforming prosthetics. Siemens, with the 3D Process Consortium, is transforming the chemical industry using AM. By creating optimized reactors with complex geometries, Siemens reduces energy use and material waste. This approach accelerates development and makes chemical production more sustainable and efficient.
Joyride, a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should look both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.
Welcome to our next highlight here on Formnext Industry Stage in Hall 11D72, and welcome in our live stream on LinkedIn this morning. Yeah, we have the AM panel now, Science and Research as an enabler for industrialization of AM. And for the one or the others, it might be a curious combination, science and research and industrialization on the other hand, and how do they fit together? Normally they are not said in one single sentence, and that's especially why we want to talk about it. And I'm very happy to have selected experts here with me on stage. Andrei Molotnikov, he's Associate Professor and Director of RMIT, the Center for Additive Manufacturing, from our this year's partner country, Australia. It's good to have you here, Andrei.
Thanks so much. Great pleasure.
Alexander Jaschik, he's CEO of ULT Group and new VDMA Vice President in East Germany, right? Or
no, that's
over
for
in Germany.
That's for whole Germany, and even better, the VDMA is looking at whole Europe. So we also have European.
Okay, so we come back. We come back to that view. Good to have you here, Alexander. Ingomar Kelbassa, he's Executive Director of Fraunhofer IAPT and is in the Exhibition Advisory Board, right? And former Siemens member, a company member. Did you watch our interview with Peter Kürter?
The last 4 minutes.
The last 4 minutes, so you have to make sure.
But at least I can anticipate what Siemens' perspective is on additive. I'm perfectly sure about that.
I would recommend to zoom in our recording of our session, because everything we do in here will be recorded, and you can watch it on the media library of Formnext later.
Okay.
So if you missed the one yesterday, we had somebody was stuck in a traffic jam, and I said, okay, you have to watch all the live stream at home. Okay, but start into our topic. Ingomar, visitors of IAPT website are greeted with the industrialization of additive slogan. And I was a little bit wow. That's quite a statement. What exactly is your offer to the community?
What is our offer? I mean, we just have 50 minutes, right?
Yeah.
What is our offer? What we have seen is over the past years that AM 3D printing is not just a process step; it's an entire manufacturing chain, from the design CAD file to the finished end good. And so our contribution, our solution approach to industrialization is not just having a process-specific look on LPBF, on DED, on binder jetting, whatever the process in additive manufacturing is, but along the entire process chain, also having a significant contribution to mainly post-processing, finish machining, quality assurance, and also with regard to virtualization, automation, and in the end, of course, historically coming from the process.
That's because you wanted to focus, because the first aspects you talked about are very important as well, so you can't let them aside.
Exactly, but if you ask larger companies, end users, what is your biggest obstacle, what's your biggest hurdle in terms of industrialization or line integration into your existing production environment? It is not mainly the productivity of one process step. It's mainly topics such as, hey, why exactly do I need 8 data formats to come from a CAD file to the finished end good? We have found out that 3D printing mainly contributes just to maximum 20% in cost and in time to the entire end-to-end time and cost in terms of additively manufactured parts. But that means in consequence that 80% plus are not generated by the 3D printing process. And that's exactly our philosophy. That's why we say AM is not a process, AM is an entire end-to-end process chain.
And that is the synonym for you for industrialization. Well, if you solve that part.
No, the synonym for industrialization is for us TRL, Technology Readiness Level 9. because you can
have to
have a
describe
look at
that. That was too fast for me.
Yeah, might be you know these, that I think NASA was generating these TRLs in the 1960s, right? TRL1 is shown feasibility from a basic principle, this process works, and TRL9 is serial implementation into, let's say, shop floors industrialization, pure industrialization. And I mean, Fraunhofer's main mission is to bridge the gap between basic and fundamental research, usually conducted at universities, and bridging the gap into industrialization, industrial environment, usually with end clients and customers that directly pay you via bilateral contract research. And that's exactly the job of Fraunhofer. Fraunhofer does not conduct any kind of basic and fundamental research.
Alexander, how important is an offer IAPT does here from the perspective of the industry?
Actually, very important. As you said already, mostly you look only on one specific point, like the laser powder bed fusion machine. But there is a whole process chain between engineering, the pre-processing, the production process itself, and the post-processing. And mostly this part is missing for most of the users. They need to see the complete picture, and that's why it's important to get results on that. What are also on the cost perspective, which is important, CapEx, OpEx. If you look at this, at the whole process chain, and to see also what are already well-known practices. And there, Fraunhofer and also other institutes have to make an important contribution.
Do you know already other companies working together in that aspect with you from the VDMA AM community?
Yeah, I mean, I think it was in July where we launched a new association that is called Industrialized Additive Manufacturing Hub Hamburg. And we do meanwhile have 80 companies, so bigger ones, global players, such as Siemens, by the way, such as Siemens Energy, Airbus in Hamburg, etc. But also many SMEs, so small and medium-sized enterprises, cooperating just on the topic on industrialization. And this is exactly the link. I look not just virtually, but also physically into your direction, yes. Andre, the link to Australia, because you are a very big part from RMIT University, is a significant contribution to what you call AMCRC, that stands for Additive Manufacturing Collaborative Research Center. It's the same topic, industrialization of additive manufacturing, not conducted in Germany, not conducted in Hamburg, but exactly the same thing, but in Down Under. And I think the budget is approximately similar to ours, so 100 million plus in Australian dollars, in euros.
Yeah, that would have been my next step to get the broader view into the international market. We come a bit later to that one. I want to keep 1 second in Germany or in Europe. When these companies and the collaboration in Hamburg you are talking about, it's not directly linked to VDMA, right? It's not part of VDMA. The companies are here and there. Both in both associations, but it's not a part of your VDMA activities.
So like I said, the companies which are already engaged also in VDMA are also surely part of this. And just to highlight this, if you look to one of the major topics still is the higher CapEx costs and OpEx costs in comparison to other production principles. And therefore, this cooperation is very important to reduce this and to give an impression also for the users.
I want to understand why is the need of a new cooperation when there is already a VDMA AM community?
Okay.
Where is additional task? And that would be the next step, asking why do we need some in Australia and some? So why not working together? Or what is the specialty? Why do you look or what do you focus on that you need an own group in collaboration on this topic? Because it should be a VDMA topic as well.
Yeah. If you look like at the typical task of a association like VDMA, there are like political tasks which need to be dealt, like creating standards, bringing the network together, and sometimes it could be better to be more for the practical parts, to have an association like you talked about, where you create like real examples in reality.
It's on a working base.
On a working base. That's a good point. Yeah.
To add on that, VDMA mainly addresses the machine OEMs, right? And of course, in our case, the majority of the 80 companies already collaborating on additive and industrialization on additive is end-user focused.
Okay.
But that means the end users do provide the specifications for the next generation for the machine OEMs to exactly fulfill what they want, because these are their clients.
Like,
it might be that
it's like
specifically.
You have the lab to the theoretical aspects.
Okay, now we want to add, sorry for letting you wait so long, but I wanted to understand that point. Now you can add, or I would like you to add your perspective on your working together with companies. Is it exactly the same approach, or wouldn't you agree?
Well, look, Australia is obviously quite far from Europe geographically, but we are very close friends. We're working with Germany and all other European partners all the time. And what excites us about is that we as a community now at that stage where we understand that we've done a lot of exciting research, whether this is developing new machines, new materials, and we want the industry now to take all of these learnings and incorporate them into their products. And the ideas of industry-driven associations is really helping them to do that as fast as possible, focusing on their needs, rather than continuing doing some exciting fundamental research. So we're not stopping that, but we are using this type of new research centers to start helping industry to incorporate all of this funding into final products, right? So as in our case, I can give you examples of large corporations, I don't know, your Boeings and other tier one suppliers, really understanding now the value proposition. And I think that's what we've done well as a community. We worked on that for the last 15 to 20 years. And it's a tipping point where we start now seeing really going from few cases to really starting to incorporate that in a production, right? And Boeing is a fantastic example, and Airbus does exactly the same in Europe, that we see many applications where additive is the right choice. And I think it's important to emphasize that you need to choose the best suitable technology and incorporate that technology into your manufacturing. So we're part of the manufacturing. We need the machines, we need the materials, we need the knowledge of everything that Ingo described, from starting the design to final products. And I think we're finally there where we can make a difference. And we're doing that across different continents, but closely talking and working closely with colleagues both in Europe, in the US, and Canada, and Japan, and so on and so forth. So it's a really exciting time to start taking on those challenges and really doing things that will make a difference.
But how do you manage the competitors in those collaborational work groups? You mentioned Airbus and Boeing, so that's a good example. Can they work closely together, or do you separate it?
I think again the industry is opening up, so we do see more sharing between different industries. Of course, it's easier if there's an automotive company and aerospace company in a project where they don't compete directly. However, there's more and more discussions around specific topics within the industry because they're facing the same challenges, right? And we have the privilege of working with all of them to some extent, whether they are your Boeings or Airbuses, and understanding how we can overcome their barriers, right? And our role is, as a university or research organization, to help solve those problems as quickly as possible and find both efficient ways of doing that, but also innovative ways. So a lot of things that we are proposing and doing with partners is starting to look at a lot of processes quite differently, and often come up with hybrid approaches where we're not abandoning the existing knowledge on manufacturing, but we're really saying, okay, well, you can use additive, but maybe we pair it together with a traditional manufacturing, and most people here at the fair understand that additive is a part of the ecosystem. We won't be able to do everything additively, but there's a lot of things that are amazing what we can achieve with additive.
You wanted to add something?
Yeah, just to add also something to the point we said before. If you look at the average machine building company in Germany, Deutscher Mittelstand, it's about like 200 employees. So most of them also, it's also to see that most of them can't afford like a machine immediately, and they don't see the use case. And at this point, it's also important to have locally, like also cooperations between universities, and Fraunhofers and so on, where there can be like joint projects just to identify use cases. For example, in my personal home region, Upper Lusatia, Saxony, we founded even a local association. We just bought a selective laser melting machine, and now different kind of companies from the region have the possibility to have access to this machine together with the universities. And then it's very fruitful to combine these, the use case together with the technological knowledge. And that's something which Fraunhofers or universities can do locally.
I had a question for you as well, so but you can add your comment.
It's just a comment because you asked. Your question was how does it work? Because you brought up the competitiveness between Boeing and Airbus. It's pretty easy because as long as the topics are pre-competitive, you can collaborate in joint projects because there's no big issue, no big threat jeopardizing your own IP, as long as these are pre-competitive
It's
topics.
similar to standardization processes. There all the competitors
for
work
example,
together
right?
as well.
But when it comes to, let's say, generic topics such as increasing the productivity, hey, so what? I mean, every machine OEM would agree on that, right? Because the customer is interested in that. So pre-competitive topics are not a question. The competitive topics are a question, but these are usually addressing TRLs larger and higher than 7. So usually you can do whatever you want to do in terms of collaboration in pre-competitive topics. And there's a second point on that. That's risk sharing. As long as you do cooperate, you are not taking the risk at your own.
Yeah.
Point 1 and point 2, also risk minimization is public funding, right? So collaboration decreases your risk, and of course public funding financially does decrease your risk.
The Fraunhofer concept, I think, is very much understood here in Germany. Is the structure you were talking about similar to the Fraunhofer concept?
It's not the same concept. So this IMCRC, which is a corporate research center, it's driven by the industry, right? But they do need a research partner. So whether it's a university or a research organization similar to Fraunhofer that we have in Australia, CSIRO. So we have to partner up together to solve a particular problem, right? So the model is to some extent partially similar to Fraunhofer, but the end goal is exactly the same. It's about helping to uptake the technology as quickly as possible and find the synergy of different partners working together. And I think what we have happening at the moment in Australia is that we have a lot of industry that identified manufacturing and additive manufacturing as critical. So even going that far is to say that our government puts not just the money, but identified that as a critical topic for us for the next 10 to 20 years. And meaning that because of this topic, we need to have the appropriate resources and helping the companies. And the companies span across a lot of industries. So you have your medical, you have your space, you have aerospace, you have a defense and minerals. So all of these areas can greatly benefit from additive manufacturing. And in many cases, I agree with Alexander that some companies are too small to do that themselves. So this kind of network really helped them to be embedded and maybe share the risk, as Ingo says, and share the investment and get faster to the final product. And I think this is what we really need all together.
I don't want to put water in your wine. What joining companies, your associations or your cooperatives, but I do not understand the aspect of it's too small companies and additive is too expensive or too mind blowing to get into the use. You can buy a 3D printer any size, any cost you can afford, and you can start. That is the message I learn here on Formnext. Go into the technology and try it by yourself. You don't need to have something some cooperative. What? It's just try to get me into your boat.
Yeah. We can definitely help you there. So it's partially correct. However, as you heard from Ingo, it's only part of the equation. If you just got the equipment and you got some knowledge from OEMs, it's not sufficient to get to the product. You're still missing out on the design, on the material, on material certification, and all of the other steps before you get to the final product. And even if you printed your product, there's a post-processing, there's other things like non-destructive testing and certification and everything else that still needs to be part of your development. And this is where most of the companies will struggle to cover all of these topics. And it's much better to partner with Fraunhofer or others who've done that on some of the products and can help you to do that faster. Mm-hmm. And that's the same kind of role we take. We help numerous companies, both in Australia or US or somewhere else, to go through that path, often being a silent partner, and you take pride of then seeing those products released by those major companies and them being really successful. And I think that's what also drives us, gets us out of the bed every day, and it's not just the beautiful weather and sunshine in Australia, but also helping the world.
So that is the offer you are doing to the community. What help could you use? Where would you need some support? What just the community joining in, or looking at maybe governmental or restrictions or documentation efforts, or I don't know, regulation could be better or easier, or what do you ask from the government?
It's not really a demand, but if you ask me like that, I would also, what we need is more optimism in these times. And what we definitely need is, let's say, speed. Because we do live, all of us do live in high-wage countries, right? Australia is a high-wage country. Germany is a high-wage country. Entire Europe is a high-wage region, as well as North America, Canada and United States. And our contribution to grow that cake of AM, to make it bigger, can just be innovation speed in comparison to all the other regions in the world that are not high-wage countries. And that's exactly what we are asking for, is give us more support financially on the one hand side, but you have, of course, mentioned also in terms of regulation, and what we need is deregulation.
Yeah.
What we definitely need is deregulation, because, you can ask our scientists in our institute, what they need to do in terms of administration is, some say it's fun, but it's not fun, right? If you spend 80% of your workday with just administration things in terms of SAP and all that stuff, then you just spend 20% with the real scientific stuff. So is that a good idea? Usually not. You should definitely make it vice versa.
Just to add this, also the VDMA made a research that for the companies in Germany, there is 3% of the turnover are bureaucracy costs. And that's the lower limit, could be also up to 5%. So this is really something which needs to change. And I hope the debate starts now and hope we will see it in the new government which come up. Okay. And as well, also one important point, to be honest, is a level playing field. And if you look at the European market and European machine builders, in comparison also to maybe some Chinese or whatever, we need a level playing field concerning the all the regulations and so on. And of course, this is something which government can do. But
That
honestly,
would be addressing the European government.
it is like it is, Föderalismus, the Germans, or the European system. There are European topics, there are German topics, of course. But to be honest, also, the main homework is also on the side of the machine builders or on the process chain. There are a lot of topics still to be solved, and it's also a nice topic because there are a lot of innovation potential still in the thing. And as you asked, maybe you said you received different kind of messages. Of course, we need to differentiate between a simple FDM printer, maybe for 1,000 or 1,500 euro, and between a selective laser melting machine, which is 1 million, 2 million, whatever. So of course there's a wide span of it. And when we're talking about high capex, of course we're talking about this fancy machines, the higher invest volume.
You mentioned that you have a good knowledge about the European market, and you are co-professor in Barcelona, right?
Well, yes, I worked in Barcelona. I grew up in Germany, so I'm also biased because I know the system here. And I work obviously for 20 years in Australia.
So when you compare, especially what we are discussing right now, regulations and the time needed to get to a solution, is it just a self-assessment that we're too slow and that we have too much laws and regulations, or is it?
It depends on the areas again. So I'm also part of Standards Australia, and I can picture or give you a picture that's quite different. And particularly if you look at our medical devices and you compare the regulations in the US with FDA and in Europe, it's actually much easier here than in Australia. So we are much more stringent when it comes to medical devices and putting implants into people, to that extent that many of our colleagues will choose to collaborate with someone in Europe or in Southeast Asia because we could do those things much faster. So innovations in the medical field are typically go somewhere else and not easily implemented in Australia, whereas in some other industries, we are indeed more inclined to process things faster because our standards body are more lenient, let's say, than some of the European ones, right? But in the same way, we're all part of the global community, so we are working with ISO, we're working with ISTM, and all of those have to work together in order to help companies, because most of the companies, again, are across different continents, right? And they need to adjust to all of these standards, and standards are good to some extent because they help the industry to really go away from prototyping to real products.
To lean on
I think
basis, like a basis.
Yes,
to
and
work.
we're all doing our part of that equation, that we're contributing to writing those standards, and we meet in the US and everywhere else, and we're discussing what's important, and there's always a conflict between, let's say, academics versus companies versus providers, and we all find different things important. So it's a finding that fine balance that does not restrict every party too much, but makes things safer in most cases.
Because I have you here on stage, I want to collect your view on the markets. We prepared a graph, and I do not have a clicker to show the graph. Maybe the colleagues can behind that you see the same numbers than I see, but maybe it doesn't work. I don't know. I tell you what. I tell you the numbers. So we have some figures here from the VOLAS report, and brought to us by Terry kindly, so that I can display them. And so there is a revenue share of the AM sector within 20 billion euros in 2023, and we see 14%. Automotive, consumer products, medical and dental, and aerospace with 13%. So they are just ahead, and others with 14. And then we have a gap. Then academic government, military with 10%, and power energy with 6%, and construction with 4%. Does this picture fits to your assessment of the market?
I think that's a very good representation. I mean, we all know Terry and how the way the data is collected. And I think my main takeaway messages sort of from the last few years is that we all manage now to crawl quite well. We're starting walking a bit faster when it comes to the AM industry, but we are still not running. And the next 5 to 10 years, it's exactly the time where the concepts like the one in Hamburg or in Australia, they are the concepts that should help us to go from running, and meaning that you have maybe less critical parts that are producing, to start producing parts that will accelerate the adaptation and industrialization of IM.
What's your assessment?
Also, I think that sounds pretty reasonable, what I heard. And the message behind could be, as always, the more complex and the part is, and the lower the numbers produced, the more AM is used. And if you look like at defense, for example, or aviation, something, this is where like AM has really its advantages. And when
you expect growing rates here, because that would be my follow-up question.
And in these branches, yeah. Mm-hmm. For the other segments like automotive, I think there's still a way to go. Especially if it comes to the, now can see it, to the mass market. I was impressed when I started 10 years ago working at the VDMA, or starting be involved in the VDMA additive manufacturing, and there was an automotive company presenting cost per part for a molded part and cost per part printed, and it was factor 100. So at this point I realized, oh, there is still a long, long way to go. But it's worth doing it. So, just to summarize it, sounds very reasonable.
Yeah, okay. What's your opinion?
I don't care. Because the perspective of countries is absolutely different. Because in Australia, the majority of GDP comes out of mining. So, digging something out of the ground, selling it to somewhere else, to China, to the US, to Europe, and purchasing back all these different goods that were manufactured in China, in the US, etc.
But that was exactly
that means their approach to additive is just another approach than us in Germany, because we have a high rate of manufacturing already and production in Germany. So in terms of Australia, they have a higher lever in terms of increasing the value add in Australia, instead of selling something that was digged out of the ground, selling the end part, right? So their perspective on additive is just another one than ours. So I don't care too much about different industries. It might be right, it might be wrong, I don't know. But in the end, industrialization means that it doesn't matter for what kind of for what kind of fields of application we do it. Just giving one example, and these kind of success stories we need to write jointly. If you have in mind, everybody is talking about photovoltaics, is talking about wind energy, etc. Also in terms of circular economy, also in terms of hydrogen. You can generate hydrogen via wind power, or might be via photovoltaics, whatever, green, blue hydrogen. Then you have hydrogen. In case of electricity, you can re-electrify hydrogen via a gas turbine. Problem is, hydrogen burns with 200 Kelvin higher temperatures in comparison to natural gas. So what you need to do is a redesign, a re-engineering of the entire so-called hot gas path. Burning chamber, the two first stages of the high pressure turbine. That is already done, but the problem is, if you fire a gas turbine as it is right now, doesn't matter from whom, you will be just remelting the gas turbine, because you are burning things with 200 Kelvin higher temperatures. So the manufacturing path of coming to these physical components, let's call it manufacture or production, is not possible via a cast route as of today. It is just possible with using 3D printing and additive manufacturing. So that means equals additive manufacturing is the key enabler for an H2, a hydrogen-ready gas turbine for the future. And these success stories we need to write jointly.
And just to underline, that's very good. And that's also the point where the cooperation between science and research and machine builders comes together to give like inspiration what could be possible. And there are still a lot of things to be identified. And if we humans always, if we look to the future, we look in the mirror backwards and think we can scale like the history to the future. But if you look like this, these are completely new ways of dealing with it. So,
but the reason I showed you the numbers,
we need this role model
we're exactly not looking behind, but looking forward, and that was exactly why I asked you that, because when I know that I have a differentiated look in the different markets, then I have different chances and I have different tasks I have to fulfill. So when you say there is a very much more mature market in Australia and you have a good knowledge of the Australian market.
I didn't say maturity. No. I did say larger chances and opportunities in terms of the GDP.
Yeah. Okay, but that is a message for our audience, I think, that you have to look behind these numbers. First question for me is, where can I expect the most growth? Where are we lacking behind? So where could we focus? Because there is much more possibilities for the future, for small startups or small companies. Where could I find some grains I can work on? And on the other hand, I can have as company I can look at the chances when there is a market chance in Australia, then I can focus on these aspects. Okay, and you already said medical is a bit more complicated in
well, medical is complicated.
Australia.
But it's actually the prime example where IM is successful, because if you go and you look at all of the manufacturers of medical devices, particularly orthopedic implants, without naming the 4 main companies, all of them are now using IM. Yeah. And in fact, the biggest users of IM in an industrial setting are medical companies.
And I want to add another example from the defense. We already this morning talked about defense, and there was not a common opinion here which one will be growing faster. I heard about the submarine project that somebody saw it on the news probably, that went from France to the consortium of US and UK.
Yes.
And so the Australian don't visit France anymore. So
that's not true. We still like the French, and this is political discussions or decisions.
Yeah. But I want to zoom in the chance that lies in here, because what I heard is that that the project in building these submarines is only possible using AM because of the scaling up process. You just can't achieve as AM. Did you hear from that project? And is it true in your opinion?
We're working very closely with Australian Submarine Agency, so that's absolutely true. So we will be building nuclear submarines in Australia. The initial ones will be built between UK, US, and us. But we're setting up this manufacturing, and again, this is a fantastic opportunity for additive, because you don't need to build 1,000 submarines. So you're building 10, they're obviously very expensive, but you're also building the whole supply chain around it, because it's actually quite a complex undertaking. There's lots of moving parts and a lot of different industries required, both in country and outside, that need to supply that. So in many cases, additive is the logical pathway, and that's also dictated by our partners in the US and the UK, who identify that as a critical industry that will help us to do that.
That was the reason I wanted to zoom in the different sectors, because when I hear as a company here exhibiting or visiting Formnext, and I hear from these projects, and you gave a very nice project with a hydrogen
gas turbine,
burning gas turbine. Thank you. So that then I see chances in focusing on these industry sectors. Is it from the VDMA perspective a topic to make to publish and to make more clearer where the different now our audience here in the hall can see the numbers we are talking about. Thank you very much to the techniques. To the sectors. So, should we publish the information, or should we bring together the information about what's going on, where are the chances, and wouldn't be VDMA a good platform for this?
Definitely, it's not. Would it be? It is already a platform. So, if you go to the VDMA section, there are a lot of models displayed where you can see or get already inspiration what's possible. And I think this is also one major topic which VDMA can do, and as well as research or other companies, to present like good examples, to give the inspiration. Because, as you all know, if you are an engineer, you need also another way of thinking if it comes to additive, how you engineer something, the concept behind. And therefore you need some inspiration. And therefore it's a good idea to have a look at it.
In 10 years.
And also just wanted to add something also, things which you haven't seen before could be possible, but also AM is, from my perspective, also a contributor to sustainability. There are also very good examples where you can go in with reduced material effort and thereby less energy effort, and make a contribution also to the sustainability aspect. And there's also still a lot of good things to come on this point.
So let's switch to another topic. Thank you very much for the graph. I want to look in the reminding minutes. I want to look at which country will be growing fastest. Which country will be ahead in 10 years from now on. So everybody's talking about China, you know, they are moving in very fast. You see each year you see lots more of products and visitors and solutions. US is stating they have a program, and with Trump elected, there could be much more money into the US business. Europe is shaking their heads and looking around, and what could we do? And Australia has big projects with in defense. So which region or country will be ahead in 10 years?
That's a high political question you ask.
So we have a high political panel here on stage.
Because actually there are also aspects which we can't foresee, like political aspects. At the moment we are living in a world of decoupling, where I say like there are America, the United States are separating somehow. Europe needs to be stand together, form a more Europe. China is going in competition, and a lot of things are changing. Honestly, I don't really want to answer the question directly, but I hope that it will lead, the competition will lead to better applications for the AM industry, and competition has been always a driver for innovation. So I hope for competition, and I hope, of course, I'm a European, I hope we will make it, but there are so many aspects to be considered.
I should shrink the time from 10 years or widen the time. Ingo.
Yeah, I mean, what I said, we need more optimism, right? So I would be the last one not saying that it will be us, right? But of course, that necessitates a paradigm shift in thinking. Because at the moment, everything is bad. We are so pessimistic across all the different industries, right? Doesn't matter. I mean, starting with automotive in Germany, right? That's perfectly clear. But it will be us if we take things seriously. But of course, yes, this is a time of challenges. But again, challenges always equal opportunities, and we need to take these opportunities seriously. And if we do that, and I'm pretty optimistic that we can do it, it will be us and not another region. So might be to be very politically correctly. Of course, Australia. I include Australia.
So Europe and Australia as combination, very friendly for the representative of the partner country. What is your opinion?
Look. My take is to try to help the whole world. I mean, it's probably very optimistic, but I think that I'm looking at IAM as a large community that does work together in many cases, and I don't think we need to be fighting over small part of the pie. So the pie is big enough, and it's about us together making that progress that will increase the pie, and then the share of it will increase for everyone. And I think it's making the right decision. So I'm glad to see programs in Hamburg, for instance, now initiating and growing, because this is the programs we need to fund in order to help everyone to see the value proposition. And I suppose that will also have the political influence to make sure that that goes beyond the Hamburg region or beyond Germany and pulls a lot of other European partners in. And as Australia, we are always considered as a very friendly, because we are, and we like
everybody knows
we like working with everyone, and are usually very accommodating. I mean, most people think that it's quite far to fly to Australia, but you will be surprised how easy it is nowadays to get there. Particularly when you talk to the generation that took a boat and it was 3 months. Right nowadays, sometimes if you're unlucky, you might be taking the train from Hamburg to Formnext. It will take you as long as getting to Australia. So a lot of people yesterday were stuck in the train, and I'm sorry for picking on Deutsche Bahn, but
friendly Australians are
everybody doing.
So
you're right. You're right.
Definitely worthwhile to come and visit us and see the opportunities. And in fact, many European companies are coming to Australia because we have quite a high possibilities in terms of.
But coming back to my question, the answer would be the world would be compete against Mars. So we would be better than in 10 years. AM on the world is better than AM on Mars.
Compete against Elon Musk, but that's probably, let's not go there.
Very philosophy answer. Yeah. Time is running fast. I want to know where you in the beginning of our talks we had a clear offer of especially from you both that visitors and companies, small companies, can make contact to you and get into projects. I want to know, where can I meet you? Are you here on the exhibition? Where can I find you? Do you have a booth?
So we are in Hall 12. Australia is very lucky in that sense that particularly the local government from Victoria is sponsoring the stand, and we're lucky to be the partner country for this year. So we are very grateful for that support. So please come to Hall 12, find the beautiful booth with Global Victoria, and you will find lots of companies from Australia representing our technological advances, and we're happy to chat to you there.
With friendly people, but unfriendly
people,
kangaroos.
And you can get a free kangaroo sticker as well if you come to our stand.
Ingomar, where can I find you when I want to join your Hamburg association or collaboration?
Yeah, we are located here at Formnext in Hall 12.0, so ground floor, booth C89.
And open for, as I said, for everybody.
We are completely closed. We do not want to cooperate.
Okay, yeah, that's a statement.
Yeah, of course. Of course, you're welcome.
We can transmit that to the audience. Yeah, and VDMA has a partner booth you already mentioned.
Yeah, also at 12.
Okay.
So if you're already on,
that's an easy way for the audience. Welcome.
You know, with one
and
also
way
my company is also on.
and your company as well. I missed the time.
It's worth going to 12.
Asking you about what your company does contribute, but the time is, if you have
50 seconds. Yeah, it's like an elevator pitch. We are doing gas cleaning systems for the additive industry. For example, like the selective laser melting process, we're cleaning the argon and nitrogen.
One of these
since 25 years.
One of these steps we need in the process to make the entire process faster and healthier and cheaper.
More productive, especially.
More productive. Okay, thank you very much for being with me here on stage, for sharing your insights. Dear audience, now we are at the end of our panel session and we are going into our lunch break. But make sure to be with us again at, let me have a look, at 2:15. We will continue our program here on Industry Stage and live Formnext TV. See you then.
let's take it real soon. You know we got what you need, baby, so take it real on.
Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2024. I hope you at home and here in the hall had a fantastic, refreshing lunch break and enjoyed your lunch so that you are fully energized for our afternoon's program. The ones that have followed us so far today might have recognized that today's theme revolves all around success of additive manufacturing and its immense potential. This afternoon, we will focus totally on success stories in additive manufacturing. Breakthrough innovations, practical implementation. This is what we want to have a look at. And to be honest, if you want to explore success, what do you have to do? You have to get a current status. You have to hear about breakthrough stories in order to compare, to have a comparison. And there are only a few individuals in our industry that can provide that comparable to the one that is coming next as our first speaker today. Please join me in welcoming none other than Mr. Terry Wohlers from Wohlers Associate as he shares the latest developments and trends from the Wohlers Report 2024. Terry, please join me on stage. It's a pleasure. Big applause, ladies and gentlemen.
Thank you, Sven. Appreciate it. It's good to be back. Good afternoon, everyone. It's great to be here. Thank you for taking time out to listen to a few words about one person's view of the industry. Really appreciate it. How many people are here for the first time? Formnext for the first time? Get them up high, if you would. Okay, how many have attended at least 5 years? A few of you. How many are from outside Germany? Maybe a third or a half. Okay, how many from outside Europe? Okay. How many have been in the industry for 15 years? Oh, relatively few. How many fewer than 5 years? Okay, so we have a pretty mixed crowd in here. We have some veterans, some people who know a lot about AM, maybe people that are learning for the first time. Hey, we're all like sponges. We're just trying to soak it in because there's so much new here. Formnext is one of my very favorite events of the year. I just feel lucky to be here, to be able to see and learn and be a part of this industry, and I hope you do too. So thanks again for being here. So we've published the Wohlers Report for 29 years. We're beginning to think about the 30th edition of the report, and some of you are contributors. Last year we had 120 people working on it from 30 plus countries, 10 of which are in-house and the other 110 are from around the world. And so it's truly a global effort. Our team, Wohlers Associates, was acquired by ASTM International just over 3 years ago. And so our team grew from fairly small to now more than 40 people. Not just our team, but also the ASTM Additive Manufacturing Center of Excellence, and then the Wohlers Associates team combined is, well, we just hired our 40th person this week. And we just continue to grow like a weed. We just, and I just feel very proud to be a part of so much expertise. There's so much talent in people who know a lot about maybe industrial applications like big equipment, and others in medical, and others in aerospace, and we have experts in metallurgy and polymers, and so it's just a really a privilege to, if I don't know something, and there's a lot of things I don't know, there's people within our team that typically does. So, and our core expertise, or at least our core focus over the years, and it was started in 1986, began to focus on AM and the following year. And over that time, we've worked with many companies around the world, in the range of 290 clients in most continents around the world, and many, many projects. So, and we continue to work on and get new projects to this day. Now we can work on much bigger projects because we have a bigger team, which is helpful. So, this is incorrect. I just now noticed this is not the 25th annual. This is the 29th. I just found a typo. I was updating this morning and somehow I missed that. So this is the 29th annual edition here. 385 pages, mentioned the 110 experts from many countries around the world. And we receive hard data, actual numbers from trusted sources from around the world, both producers of machines, materials, as well as users of these products. And the users range from startups to some of the biggest companies and brands from around the world. And this is a subset of that. These are service providers and contract manufacturers from around the world, and you can see where they are located. And so, yeah, we feel lucky that they're willing to supply us with information year after year so that we can then put together composite totals and report these numbers and charts and graphs like we see here. So this is one that we published for many years, but the numbers change every year because the data changes as we bring it in. And one trend is this, and we saw this coming years ago, that more and more companies are using the technology for functional parts and end-use products. And will this grow to 100%, this category? Raise your hand if you think it will. Oh, you're raising your camera, but not your hand, right? Okay, yeah. No, it won't, because obviously people will continue to use it for tooling applications, jigs and fixtures, and aesthetic models, and so forth. So those categories will continue, but we will see a growing number of companies using it for series and custom production parts. Now, we've all seen heat exchangers. They're on the show floor here. And many of these examples that we see are demonstrations. They're not really used for serious products. There's like, this is what's possible. And it shows the inside using a gyroid type configuration to really make it efficient. And, half the size and 4 times the efficiency is staggering to me, to be able to do that. But what good is it if you're not really using it on a serious product? Well, we are seeing that, and here's an example of it. So a heat exchanger has been certified for installation on the F-35, which is the most expensive, the biggest program in the history of the United States, military program. Enormous amount of money was spent on this. And a 3D printed metal part is going onto it, which I think is pretty cool, because this is not a trivial part. And so this is the kind of activity that we're seeing go on behind the scenes. Let's look at the industrial sector. So we estimate, based on the hard data that we collect, that the industry was just over, a tad over $20 billion last year. And so how's that divided up into these industrial sectors? Well, this is it right here. And so if you look at it in the context of production applications, these two sectors really make up, they were among the early adopters of series production, a lot of custom work as well, or at least short run production. And then the second wave, I think, has really come from government programs, healthcare, but the biggest is automotive, even though relatively few automotive companies are really scaling to the point where they're using it for series production, with the exception of companies that are only building a few thousand cars per year, like the Lamborghini and some of the high-end vehicles. And so, but we are starting to see, like this Cadillac. This is a GM car in the United States. They're beginning to print a lot of parts for this automobile. They're printing in aluminum the steering wheel, as well as 114 other parts by additive manufacturing. And you can see aluminum, stainless steel, various types of polymers using powder bed fusing. They're using binder jetting as well, metal binder jetting, and also metal powder bed fusion, which is the example that I'm showing in the upper left corner. So this is something that's relatively new to see this kind of activity. Still an expensive vehicle, and we're not talking about hundreds of thousands of cars or a million vehicles. It's getting there, but we believe that once it does, it's going to drive costs downward. We're all going to benefit from it. Better quality, more reliability, and more affordable for the machines and the materials. Another trend we're seeing is surface quality. This is a company that I've known about for about a year. I saw it at Rapid TCT earlier this year. They are here, I forget which hall, but I was reminded that the surface quality right off the machine is staggering. I mean, it's just really impressive. Using sterile lithography, this is an example of a single cavity, or actually a two cavity mold. And so they can get from the part to a molded part within a very short time, even within the same day. And that's pretty impressive. These are parts that are grown directly. It's 100% pure silicone. And because the surface finish is so nice, it looks like it's a molded part. It just came off a mold, but it didn't. And so have a look if you're interested, and if that's important to you. Surface quality, speed, those are two areas in which we've been plagued. I mean, it's much faster than tooling if you're doing a certain quantity, but it's much slower if you're doing high quantities, typically. And so it's good to see that we are making progress with both speed, but also surface quality. Automation's a big one as well. AM Flow is a company that it's worth a look. We're seeing them do part sorting and online real-time inspection. And the cycle time per part is about 5 seconds. And it can sort it and even put it in bags. And this is the thing, if you can automate and reduce the requirement for labor, then you can compete with almost anybody in the world. So this is an important step, not necessarily AM Flow, but the idea of reducing labor to get to final product and to your customers. This is another development. So I know the print is quite small, but let me just say this, that this is the build volume of the EOS M290, which is a very popular and well-established platform. And this is the build volume of the large Nikon SLM Solutions NXG. And these four are from Chinese companies. Now, I'm not suggesting that bigger is always better, but it's impressive what these companies are doing in China. Anyone like to guess at how many Chinese companies are at Formnext exhibiting? How many? 20? Okay. No? Anyone else? 100? Exactly 100 have exhibits. Another around 30 companies are distributors here that are selling Chinese products that are separate from those 100. So about 130 companies with 100 exhibitors. And that's a lot of companies out of 860. At Rapid TCT, we had 42, which is, I want to say it was about the size of this Hall 11, give or take. Would you agree? Yeah. So keep an eye on what's going on outside of Europe, US, and other countries. How many people are members of ASTM International? Next year at this time, I want more hands to go up. So, but even if you're not a member, you can participate in industry standards development. And ASTM and ISO partnered in the 2011-12 timeframe to co-develop and co-brand standards. Standards are so important to mature an industry, for it to really develop. And I mean, imagine if we don't have lighting standards or computing standards or standards on construction materials. It wouldn't, so standards are vitally important. So, and any of us, all of us, can participate in the development and even go to the meetings. You don't have to be a member. You can go for free. But if you want to vote, you pay, I think it's $110 for annual membership. But in any case, these consensus standards are so important, and they're, like I say, being developed by people like you and me, that really is so important. And I'm wrapping up here quite soon, and then if we have time for questions, we'll take a couple, but I'll leave that up to Sven. So we've done this for many years, really looking at trying to quantify the size of the industry, really the products and services that make up the additive manufacturing industry worldwide. And we estimate, based on the hard data that has come into us, that last year, as I mentioned before, about 20 billion. We think it's going to, approach 100 billion. We're always back off. We don't like to give these, outrageously, almost unbelievable forecasts, because we like to start out by extending our growth trend line. That's a good place to start. And, we bend it up or down based on a lot of factors. And so, if anything, we want to be a little bit low, and then years later report that maybe it's a little better. But in any case, we think that this is realistic, that the blue bars are historical, the yellow ones, yep, they're yellow, are forecasts. So, I mean, it's sizable, but, to put it into perspective, there are some companies that are valued at more than $20 billion. Single companies, not necessarily additive, but, if you think about it. So it's still a relatively small industry, but consider the value that it provides, like that heat exchanger. And it's hard to quantify the value of these parts that are going into some of these products and new businesses that are being developed as a result. We don't take that into account. We don't. Just the products and services directly associated with additives. So this is really a relatively low number compared to the actual value it provides. And then if you look at the annual average over the last 36 years, it's grown 25%. Every year on average for 36 years. In the last 10 years, about 21%, just a little more than that. So, in summary, quality data really shows us trends. And that's important. I added the word quality just recently because you can get data, but what if somebody, here's a case in point. What if a company started in 2021 and then 2 years later they reported, yeah, we grew by 400%. Well, it's easy to grow, if your income is very small and then you grow and they report that to us of 400% growth and add that in. No, that's an outlier. You throw it out. You don't use that data. So that's the kind of thing we need to use some intelligence or experience, I guess, to be sure that the data isn't skewed based on these outliers so that we have good quality data. And then applications, and this is something that Fried Van Creen, he's the founder of Materialize, and he says, Terry, applications are going to drive growth in the future, and I couldn't agree more. I talked to him just yesterday, and he just gave 3 examples of some trends that he's seeing. All 3 of them, coincidentally, were applications that he talked about. I said, Fried, do you remember that statement you made, a few years ago? And so it was kind of an interesting conversation. And then I think recent developments that we're seeing here, yeah, there's a little bump in the road, a little dip. I think we're at the valley of the, I don't want to say the challenge that we're seeing, but we've seen that over the years. The growth's like that, but if you zoom in on it, it's like this, and it's growing. And we're at the, I think, no one knows for sure, the valley of that dip. And I think that what we're seeing out here really supports an optimistic future. So thank you very much for your attention. I appreciate it.
Big applause, ladies and gentlemen, for Terry Woolard. Terry, I mean, first of all, any questions from the audience? That they should be first. Is there any question you want to ask? I was already, they mentioned already to me that we are running out of time, but allow me one question. You mentioned at the very beginning, this was the 29th Wohlers report. So was it sometimes frustrating? Because, you know, if you are at that pulse and you are so close to the core essentials of what the industry is doing, and you are a consultant additionally, is it sometimes frustrating that we are not faster and we came not faster to this point of industrialization where we are today?
Frustrating that we haven't grown faster?
Yeah, for you, from outside?
You know, a lot of people, many people, even myself, I think, you know, why haven't we grown faster over the last, you know, 25% in the last 36 years? That's not bad. 21%.
Which is great.
Yeah.
But I mean, at least for me, it feels, and I'm quite a bit in the industry, it feels the first time that we're really talking about industrialization and have the first success stories. So this had taken a long time in order to elaborate, isn't it?
You know, Sven, so part of the challenge has been systems and materials. But I think we've mostly solved that problem. Yeah, there's a room for improvement, but it's everything that surrounds those. It's the pre-process, the design, and streamlining it, and then everything that happens after. You know, the post-processing, the qualification, certification, the education, training, getting talent, and keeping that talent, and really, you know, end-to-end workflows. And so that, I think, is our biggest challenge over the next, you know, foreseeable future.
Very good advice, by the way. Tomorrow we are discussing skills and talents, so please be there at the stage. So we are running out of time. Anyway, thank you so much. It was.
Oh, can I say one more thing?
Yeah, of course. Go ahead.
Oh, yeah. So on Monday we had the AM Innovation and Standards Summit here on site, and so our next speaker, Lauren, where are you? She will give a summary of that. So I really...
That's what is written.
All right. Thanks, Ben.
Thank you so much, Terry. It was
You're
a pleasure.
welcome.
Thank you so much. Yeah, ladies and gentlemen, that was Terry Wohler's exciting presentation as always. And as he mentioned, so he took my moderation, which is totally okay. So you will enjoy a little bit of our highlights here from Formnext. And after that, we are stepping into the topic of standardization and why it's so important in order to speed up and keep the pace we are currently having in our industry. See you in 2.5 minutes.
In my job, the slightest change of weight makes a difference. Thanks to additive manufacturing, we can switch out the heavier parts to their lighter counterparts. At Formnext, I get to work shoulder to shoulder with the AM community and push the boundaries of possibilities. Solutions presented at Formnext for materials or production systems become increasingly effective year by year. Another great question of using AM are the significant material savings. Simply put, AM celebrates sustainability.
AM Systems innovates with its multi-laser patterning module, combining multiple laser beams for high resolution and productivity. This scalable module delivers precise targeting at 20-micron spots, paving the way for the next generation of high-quality, high-volume industrial 3D printing technology. Fraunhofer IGCV developed a patent-pending powder bed fusion process that produces battery cell housings from aluminum, copper, and ceramic in a single step. It simplifies production, offering design flexibility and faster prototyping, which accelerates the development of advanced battery technologies. Toolcraft created a dry ice blasting system to remove support structures from metallic 3D printed parts. This semi-automated solution improves production efficiency, quality, and ergonomics. It reduces cycle times by 15 minutes per part and streamlines production. Additionally, It enhances the work environment.
Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2022. Day 2, ladies and gentlemen. We are already in our afternoon program, and we just enjoyed a fantastic presentation by Terry Wohlers about the current status of our industry. He mentioned one very important thing. He was talking about success stories. He was talking about how we develop further business in our industry, and one crucial factor for the whole thing is standardization. Because if we want to get additive manufactured parts in airplanes, if we want to have them in our industry in a serial production, we need standards in order to ensure that this is working all over. And as Formnext is supporting it, on Monday, leaders from ASTM International, ISO, America Makes, and the US Commercial Service came together with industry experts to discuss how standards can accelerate the adoption of AM and cut cost. And we want to, of course, hear what kind of results we can expect from such a summit. And there's a person that will share who will share the insights of the summit. And therefore, I welcome Dr. Lauren Edney from ASTM International here on stage. Lauren, it's so good to have you. Please enjoy the presentation. Big applause, Lauren, ladies and gentlemen.
So good afternoon, and thank you very much for that warm welcome. So thank you all for coming today to hear a little bit of a wrap-up of Monday's AM Innovation and Standards Award Summit. So today I'll share a little bit of insight into the sessions that we held and the outcomes and the key takeaways, and also a little bit on the ASTM International's journey and how we've kind of got to the point in which we have. So, let me begin with a very quick overview of ASTM International. So ASTM have been going for the past 126 years, and we've really driven standardization across a number of industries and a number of technologies to drive that industrialization of technology. But in the past 15 years or so, we've really went through a transformation. So additive, obviously, we're all here, has seen a really big up and coming. So we've got the ASTM AM Center of Excellence. We are now, as Terry mentioned, a team of 40 individuals, and we are split across 4 continents, and we have to battle 11 different time zones to do our work. But ultimately, we work across 5 different pillars. We look at research, training, workforce development. We've got a number of consortiums, and we'll also carry out some advisory services with a number of kind of project sponsors, as you can see down here on the bottom. So, our topic on Monday was all about cost effective, but and unfortunately, I can't show you all of the projects we were involved in, but we can take a look at our government projects. So here we have a whole range of projects, and increasing with Navy, US Army, America Makes, National Institute of Standardized Technology. And we range a whole load of projects covering some really key topics. Training, qualification, certification, all the way through to AM economics. So we've been doing this for quite a long time, but what's really the backbone of all of it is standardization. So as this is now our 4th year running, the AM Innovation and Standards Summit. So first up, thank you to all our partners we run this event with, and thank you to Misago Formnext for putting on this event. Also to the US Commercial Services, ISO, America Makes, and then also the ASTM International team. But as the years have gone on, our event has progressed and changed, and we've driven a number of themes through our event. My boss likes to call ASTM the town hall. He says if our industry comes, they can have a platform to share their troubles, their worries, what they need fixed within additive manufacturing. So we started in our first year with the industrialization of AM, and we have now worked through to driving cost-effective AM through innovation and standardization. But one of the first things that was said on Monday's event, what is innovation? And there's a really key point, I think, to this topic. Innovation is adaptation. We are all pushing forward novel new technologies. But without adaptation, we can't innovate. Without adapting, we can't move forward. So, cost efficiency. And one of the best things about standards, we've got loads of them, so we can give you some right initial quick wins straight off the bat. Slade Gardner, best thing about standards, you can choose from so many. And typically, the best thing about standards is also that you can reinvent the wheel. So we need to get that quick win and stop doing that. So, first question, is your standard available? In a lot of cases, yes. You might not know about it, but your standard will be in progress somewhere. What are other industries doing? So Formnext gives you a key platform to understand this in a wider platform. And then finally, can we take any learnings from other industries? So what have those before us done? There's some really key similarities, castings, composites, forgings, that have really driven to get us to where we are today. So I want to start off by giving you a bit of an overview of the talks that were held without actually re-giving these talks. So we had 5 keynote speakers on Monday, came from a range of different industries, and all amazing. But one in particular really drove home actually why we are here. So Sebastian from 3D Systems gave a talk on metal AM applications, and he discussed a case study of a young 10-year-old boy. And in December, on the 28th, he was in an accident on his grandparents' farm, a terrible, horrible accident. A chainsaw snapped and embedded within his skull. 3 weeks later, that child was back at school through the benefits of AM. So that really kind of tells us why we're doing and how important what we are doing is. So, these talks were then followed by a number of breakout sessions, and we covered a whole load of industries. We looked at software, we looked at aviation, space, medical, and energy and oil and gas, and then also, of course, standardization. I really thought when we were asked to give this presentation that I'd kind of walk you through all of these different sessions, these breakouts, and give you a bit of an overview. But unfortunately, if I was doing that, I'd be standing up here repeating myself quite a lot, and you'd probably all turn around and walk out. But I think that's actually a really critical message to be giving. There is, 7 different industries up there, and you've all got a common problem that needs to be solved. So how do we try and get that down? So for the past 4 years, we have followed a standardized approach. We have looked at the state of the art. What's new, what's now, what's most relevant, what are we doing of tomorrow? Where are those opportunities? And what challenges do we need to break down to get there? And what enablers do we also need to consider? So, first up, cost-effective AM. It's all about driving cost efficiency. We can now do qualification. We can certify components. And now the question that in our town hall we have been asked is, how do we make that cheaper? How do we make that more cost-effective? But is cost always just cost? Is it always just the pound sign that comes before it? Or actually, is there added value that we can be gaining elsewhere? Medical industry is a key one. How quickly can we get a patient back to school? Or, if you're in the front line, how quickly can I get you back to where you need to be, safely, without any issues? But how do we quantify that? What are the techno-economic models that are in place? So ASTM have been working on a techno-economic project with American mates to develop these models that hopefully, in the very near future, will be going into a standard that everybody can use. But we still need cost effectivity. And that takes us on to our supply chain. Digital inventory. Again, cost reductions the need for digital twins to provide a global access. I could be sitting in America with a digital twin of a component, and I could send it over to a colleague at the other side of the world to have it printed where it is needed. I don't have to be scurrying around to find someone that can then redraw my part, rescan my parts. We can do that all in one swift movement now. And again, standards are always a solution. And this is what we were trying to tell people on Monday, that chances are something is out there. So, ISO ASTM standard 52951 is currently under committee review. This is looking at the development of a digital twin for AM parts. How do we tie digital twins, the data we need for the digital twin, and how do we then tie that back in to the AM part? Data. Data is a big one, and a lot of people today and over the next couple of days will be talking about data. We collect tremendous amounts of data with our processes and with our machines. We've seen the scale. We've seen Terry's message about the size of new powder bed fusion, laser metal deposition machines. They are just going to get bigger and bigger and bigger, and that means more and more and more data. So that's already a quick win in itself. We collect that data, but it leads to a lot of uncertainty. Why are we collecting that data? What am I doing with that data? And actually, what do I need to track? What do I need to keep a hold of? And how can I reduce back down the data that I'm taking in? And then also, what's the future capability of that data? How can I use that tomorrow? How can I build my models around this data to deliver my digital twins? Data is a big, big part of what we do at ASTM. We've got the Global Consortium for Materials, Data and Standardization, or some of you may know it, CMDS. We're using requirements and best practices through our standards to deliver trusted material and data that we can then use to generate a high pedigree data collection that can be used as a data management system across a consortium. So everyone there has got access to that data to then drive also standards development, drive trust within your industry, and also within your high-up stakeholders. And another big one, especially as we're in Europe, sustainability. In the next couple of years, you've got some really, really strict regulations coming in on what you can put back out into the environment. So we need to start looking at things like material efficiency, our design optimization. How can we make something lighter? How can we remove material that's not quite needed? And then also, at the same time as doing that, we don't have to machine that material back out. We're just laying down what we need in the first place, so we can reduce our material waste. And again, in Monday's event, someone stood at the front and said medical grade PEEK costs $5,500 per kilogram. And your conventional manufacturers are wasting 90% of that kilogram for every part that they make. That's a lot of money. And it's a lot of reduced material when you can't then do anything else with it. And then finally, sustainability can also drive supply chain optimization. Make the part where we need to make the part, rather than having to deliver it halfway across the world. Making your forgings in Japan when actually they're needed in Europe or they're needed in America. The supply chain, the delivery cost you can save are astronomical. The one I'll harp on about a little bit. Standards. Being the Standards and Innovation Summit, we did think this one would come up slightly, but pretty much across the board, everyone said there was a need for a common language within standardization, and a need for more standards. Please, no one tell Slade Gardner. But you can see in the past 5 years, the numbers of standards available have seriously increased. I mean, the past few decades, we have released 75 AM standards in partnership with ISO. And you can see from this graph here, our trajectory is getting quicker and quicker and quicker. So more will be coming. We also talked about standards within testing and evaluation. Could we use standards to provide a safe zone for components so you can then reduce the testing and the post-processing that you need to do to, again, bring down your cost? I can provide you a safe zone for your components above it, scrap it. If it's below it, scrap it. But in that middle zone, you're safe. You then don't have to do your X-ray CT. You don't have to do all your tensile testing. And again, with these standards, you build trust. Build trust in your material, your components, your systems, and also in some cases in your testing methods. You'll see down in this hall. And then finally, personal qualifications. How can we get everyone in a place where they can walk in and be like, I know I'm going to get consistent quality? Personal qualification. You can get trained operator certificates. You can get facility requirement certificates. So everyone can be singing from the very same hymn sheet. And as everyone says, a rising tide will lift all boats. Our standards are driven by consensus. So unfortunately, if I decide I want this wild and wacky idea, someone is probably going to tell me no. But consensus brings everyone together, and it ensures that our industry is moving forward together, collaboratively. So consensus through standards will lead off to our best practices within the industry. And that's what we really need to continue this drive with AM. And at that, thank you very much for your attention. And another self-plug. I'd like to just point out ICAM in October. It is in Vegas. We can thank Mohsen at the back for that one. And there we go. If anyone's got any questions, more than happy to take them.
Thank you so much, Lauren. Big applause, please. Dr. Lauren Elney. Any questions from the audience? So far not. I mean, you explained it fantastically, so there was no too much room for questions.
Perfect.
But honestly, I mean, I remember the recent years, to be honest, as an outsider, you came into and you talk to some companies and they tell you, yeah, there's still a standard missing.
Yes.
How do companies approach you? Is that something where you gather companies and say, we need a new standard on this topic? Or is it like by market research? Or are companies coming to you and asking, is there already a standard in place?
Yeah, so it's platforms like this. I was approached this morning from a company in oil and gas, and it was have you got these standards? We need these standards. Okay, so if we don't have that standard, we can then put the roadway in place to get you that standard if it's what's needed within your industry. But my first point is always come chat. Don't struggle through standards. I appreciate also, I've said there is a lot of them, and it can be an absolute minefield. So come have the conversations. We can guide you through that path, and we can support you on that journey as well.
Let us take a practical example. So let's say I want to deliver 3D printing products or a process, whatever, to automotive industry or aerospace or military. That are the ones we're talking about all the time right now. So, and I want to know what their standards are and how they match to my product. That would be something as well where I talk to you and get support.
Completely, yeah. Okay. So we've been looking at some programs at the moment where we're taking all of those requirements from the various industries. And actually, in a lot of these standards, there's a lot of things that are equal across all industries. You know, your environment, your facility, your operator training, for example, they all need to be at a similar level. So there's no need for us all to have a different certification qualification spec. We can drive 80% of that is a common shared base, and then we can just add a bolt-on for automotive, for defense, medical, whoever.
Allow me one last question, because I'm really interested. So if generally speaking, there are some ISO norms or standards where you say you need to have them in order to be recognized as trustworthy. Let's put it that way. So is there already, let's say, one standard that you can point out in additive where you say this is the one you have to have in order to be a good trustworthy additive manufacturing company?
Do you know what? I would go back to basics and say terminology standards. And 52900 is key, and also our facility requirements, I would say, is kind of your starting point. There is a roadmap to standards within a standard in 52920, I believe it is. Do not quote me on that one. But yeah, I would say that's the real starting point, and then grow from there.
Awesome. Lauren,
Brilliant.
Thank you so much. Good luck for the rest of the fair. It was a pleasure to have you on stage.
Thank you very much.
And hope to see you soon. Thank you so much.
Thank you.
Big applause, ladies and gentlemen. Dr. Lauren Elney. Yeah, ladies and gentlemen, we will provide you with another few highlights. I want to just remind you of something. You know that tomorrow we will hand over the Formnext Awards. And you are still able to vote on our platform in order to give an additional juror's voice to the awards. So please do that, don't forget that. Give your vote, because you can directly influence the outcome of this election, and it's super important for our startup. Thank you so much for that. See you in a few minutes.
AI Build is a software company. It provides a very advanced platform to generate advanced toolpaths for industrial machines. We have parts from our partners that we have done in collaboration. We have live printing with the KUKA cell. We also have our collaboration with the CNC Robotics, Sika Materials and Total Machining Solutions in UK, as well a beautiful tool from Ingersoll, the Kamoji group, as well some beautiful parts from Fronius. At the fair we offer our software AI Build version 3, which is what we have been working for over a year now, that we are releasing today at Formnext. We have a few capabilities that we are releasing, from automation on making molds that we call Mold Designer. So now the user is able to only import their A surface and automatically create ribs and forklift holes for the manufacturing process. The most important feature of AI Build platform is our unique architecture. It's based into visual programming. That means that we can have very flexible control of the engineering workflows. We can have engineering workflows that are very simple to use, but also very advanced for very complex processes and applications. AI Build is a software company, and the benefit for our customers is our team. They will have close communication with our team at all times. They are specialists, and that reflects on our software. Come to our booth. Our team is here to welcome you. Please visit our website ai-build.com.
Virtual worlds offer me the freedom to rethink structures in a completely new way. Together with the Formnext AM community, I bring these construction designs to life every day.
"3D Printing Nerd" is a YouTube show hosted by Joel Tellen, exploring the world of additive manufacturing in depth. With expert interviews, tutorials, and demos, it makes complex 3D printing technology accessible and fun. It educates a global audience about the future of manufacturing. Stanley Tong has been pivotal in driving additive manufacturing adoption at a major vehicle manufacturer. His tailored training programs and expert network have made 3D printing accessible to thousands. This has ensured its integration across all levels and boosted AM adoption within the organization. The University of Stuttgart, in collaboration with the University Clinic Freiburg, developed innovative dental bone grafts for treating bone defects. Using ceramic-filled resins and precision implants optimized for DLP stereolithography, they advance bone regeneration, expanding additive manufacturing's role in dental care.
Hello and welcome back, ladies and gentlemen, here on the industry stage at Formnext 2021, day 2 afternoon program. I tell you, the more exciting things to come, and now the next program point is one of them. So let's be honest, the most exciting business cases are those where additive manufacturing plays an element role in a groundbreaking innovation. When I studied the topic of the next presenters, I was immediately keen to hear the background story, to be honest. They have been revolutionizing grocery supply, and additive manufacturing was part of their solution. And I'm super keen to hear what I'm telling, and I can tell you, I looked already on their homepage, and it's really a great story to hear. So please welcome with me on stage 2 speakers. There's Dr. Chiara Ceccato, engineer at Ocado Technology, and Sophie Magnussen, Senior Mechanical Design Engineer at Ocado Technology. Please, welcome.
Good afternoon, everyone. Very exciting to be here today, talking about how our company is transforming robotics with additive manufacturing. And we'll be telling you the story of the 600 series bot. Let me start by introducing Ocado Technology to you, for those of you who doesn't know it yet. Ocado is one of the leaders and pioneers in robotics and automation, and we are responsible for maintaining and creating the Ocado Smart Platform, or OSP. This is an online shopping and delivery platform that connects users to customer fulfilling centers. The video is not playing, unfortunately. But anyway. So the Ocado Smart Platform is an end-to-end shopping and delivery platform that connects users to customer fulfilling centers, which are huge warehouses where hundreds of thousands of bots are running on top of a 3-dimensional grid. Yeah, here we can see. So you can see the bots running on top of the 3-dimensional grids. These bots will pick up grocery items and non-grocery items, will collect them in pickup stations where human operators or robotic arms will prepare the order for the customer to be delivered. So these bots are moving according to advanced machine learning algorithms, where the optimum path for them to collect the grocery items is chosen, depending on the number of orders coming in. And also, they make sure the bots won't collide against each other. And here you can see real sneak peek inside our warehouses. And these bots are the bots before additive manufacturing. So as you can see, they are made of traditional materials. And they move inside the warehouses, again, picking up the grocery items that the machine learning algorithms guide them through. And the workload is homogeneously distributed among them, depending on the number of orders coming in, depending on the time of the day, and depending on the day of the year. I'm gonna explain a little bit more how our grid is created. So it's a 3-dimensional grid, as I said, which is a structure inside which different totes or containers of grocery and non-grocery items are stacked on top of each other. And the bots are moving on top of this, and then they can pick up these boxes and then bring them to the pickup stations where, as I said, either humans or robotic arms prepare the order for the customer. And the bots are moving up to a speed of 4 meters per second. They have a clearance between each other of 5 millimeters only. And they have 8 wheels. Depending on the direction they move either in X or Y direction. And depending on the direction they move, they will lift or lower the wheels. And they position, when they need to pick up the items, they position on top of the cell, and then they will have a hoist that can grab the tote from the bottom and then lift it up. So Ocado is a grocery in the UK where it was born, but it sells the platform to different retail partners. And we have a presence in Europe, in the United States, in Canada, in Australia, Japan, Saudi Arabia. So in many parts of the world, this is really happening nowadays. But now, let me take you through the journey from the 500 series bot to the 600 series bot. And let's see how we made use of additive manufacturing. So on the right-hand side, you can see the 500 series bot. It's the one that was displayed earlier in the video. And it's the one that is mostly used currently in the warehouses. These bots are, as I said, made of traditional materials, mostly steel, traditional manufacturing methods. And they are the flagship product currently, or they have been the flagship product so far. They have been developed after the 400 series, which you can see on the left-hand side, which was the very first generation of bots. This was developed by an external consultant, while the 500 series was the first bot internally developed inside Ocado, where some improvements have been taken on. But while the 500 series bot was still under final development, a small team of engineers in Stockholm, Sweden, started to brainstorm on how we can improve this 500 series bot and make it lighter, make it faster, make it better. And so, as I said, a small team of engineers started in a co-working space in a university campus in Stockholm. And in 2020, made the first concept prototype where a skeleton of carbon fiber tubes was used, and which connects a series of blocks that were 3D printing. And the idea was to start by applying lightweight structure principle to see how far we could push the change. And we decided in our work that we would not use additive manufacturing only for the prototyping, but we would try to use it for the whole production phase. So we wanted the bot to be as much as possible made of additive. And the reason why we decided that is that we could take advantage of the unlimited shape possibilities that additive can offer. And you can see here, well, on the left-hand side, as I said, the very first prototype that was put together by this small group of engineers. But then rapidly, we started iterate faster and faster, taking advantage of the potential of additive. In the middle, you can see 602, which was one of the many iterations that we've made in 2022. And then on the right-hand side, you can see 615, which is the one that is currently displayed in the HP booth, if you want to see it. And it was developed in 2023, and it's the first production bot that is actually being used in the warehouses. But because we are moving fast, again, thanks to additive, we are already developing 617, and 618 is in the plan. And the reason why we do this many iterations is because we can every time improve. We print it, we test it, and we improve what needs to be improved. So the result is that the bot is almost 1/4, 1/3 of the weight of the original 500 series bot, which means that it can move on lighter infrastructure, so the grid where they move on can be lighter. The batteries can be lighter because they have less mass, and implying reduced energy consumption. And overall, for the business, also cheaper product overall. But now I'm gonna give the word to Sophie, who is gonna deep dive into our additive first approach.
Thank you, Chiara. I am going to take you through the internal additive development we have in Ocado. We work on a fail-fast strategy, so we iterate fast, we implement fast, and we discard fast. And we use Onshape as our CAD system to develop all of our parts. And then we use Material Magics for the nesting and build preparation of our files. And then we print all of our files with the HP 5600 printer. And then we assemble and test the parts and assemblies in-house. All throughout this process, we communicate in Slack and add tickets to Jira for stuff that we can improve. Firstly, in Onshape, it's our single source of truth. It's sort of a PDM system that's built in. In this CAD system, we work within branches. So there's always a main branch where we develop our parts or assemblies. And from this branch, you can branch out where you can do the development work. This means that we can do multiple development work simultaneously and still have an available single source of truth part or assembly available. And we also have a lot of topology optimized parts in our bot. And they start out in Onshape as non-design volumes. These volumes is the area where the part has to be contained within. And to this design volume, we also create non-design volumes, NDVs. They are there to preserve the features that are important to keep. And when we have made the design volumes and the non-design volumes, we put these parts into NTOP, which is use implicit modeling to remove volume from the part. It uses the non-design volumes as places where material should be kept, and takes away up to 70% of the rest of the material. We have an automatic pipeline which takes the parts from CAD into NTOP, and then we get multiple solutions that shows the stress and the displacement outcome, and then we pick the best outcome out of these. So overall, we can make the bot up to 3 times lighter. And the next part is the build preparation. We chose the MGF 5600 HP printer, but before we can print, we have to make some build preparations. And our build prep, it's consistent of 4 build chambers. So one 600 bot fits into 4 of HP's build chambers. So we nest them, the parts. You can see like an example here, where they are all put together. There is up to 300 parts that are AM in our bot. 167 of them are unique parts. When we nest these parts, we try to maximize the build volume and the nesting density for our application. To our parts, we also apply serialization and feature markings to be able to inspect them later and keep track of them. When we have prepared the build chambers, we send them to HP's process development tool, which is their slicer, where we also further can adjust the printing to print as close to nominal as possible. And then the next step is the printing part. Each nest takes up to 12 hours to print and 34 hours to cool. This means that within 6 working days, we can produce an entire bot. And this adds to our fast iteration. After the printing, we post-process the parts with a blasting cabinet, where we use glass beads to clean the parts. This is essential for the next step, which is assembly. This is our fully assembled bot. Like Chiara said, it's based on a carbon fiber tube frames, 3 of them, and then the parts are glued on. We also use jigs to contain the bots inside our wanted envelope. Our bot, it contains its weight is 30% additive, and 20% of the parts are additive, and up to 50% of the structural parts of the bot are additive. And when we have assembled the bot, we move on to the testing part. We test in-house on our own little grids. And after just 7 days, when we have printed the bot and then we have fully assembled it in another additional day, we can get it into the testing site. And throughout this process, we communicate in Slack and feedback into Jira, where we create the tickets to improve our design. And then we start over the whole process again in CAD. Yeah. Thank you so much for listening in on us.
Thank you so much, the two of you.
Thank you.
So let me ask you a few questions before we ask the audience. I'm pretty sure there are some questions. So how many of them do you need? Because that was what we saw in the video is just a single warehouse, right?
Yeah.
How many bots are running there?
Yeah, like we're still launching, so we have a production site, so we're not fully launched yet. But like in-house, we have, like in Sweden, we have maybe 7 bots running on a grid, but we have much larger.
On the test grid or
on the test grid?
Yeah,
on the test grid. Yeah, that's what I saw on the homepage.
So
yeah.
in the Sweden Development Center, we have, let's say, around 10, but then in the UK Development Center, we have more because the headquarters is in the UK. And then we are starting production right now with the aim is to have 100,000 of them.
Yeah.
Yeah, that would be my next question. What is the volume overall in the world we would talk about, comparing the 500S series to the 600S series? How many of them will be built then in the future?
I'm not exactly sure.
I think we are gonna, the aim is to convert all the 500 series to 600 series gradually. So in our biggest warehouse, just to give you an example, in our biggest warehouse, we have 100,000 of them for just one single warehouse. And we have hundreds of warehouses all over the world. So we are aiming big.
Quite a number, yeah?
But yeah.
So is there then a need to improve the printing speed? I mean, that's why you already do nesting, I guess, in order to optimize the
printing speed. We use top-opt because of that reason. Then we can remove as much mass as possible, and we are constantly developing that so that the bot can be more lightweight.
So I'm, first of all, a question from the audience, because I'm very keen to that topic. Any questions from the audience? If yes, and I can't see you, give me a shout, okay? So, one more question. I'm not the grocery expert, to be honest, but I love things that been automated, because in the end, as an end consumer, it will be faster, right? I mean, I put my order and I get it delivered home very quickly. So, talking about stability of the bot, I mean, because you reduce weight to a certain amount, you increase the additive manufacturing parts. So what weight the bot has to, the bot has to wear, and are there any constraints with additive regarding the, let's say, task he needs to do, the bot needs to do?
I can start answering. So I would say the first challenge that we had with additive was to make sure we know very well the material properties of the PA12 material that we are using. So, of course, the properties of steel and traditional materials are very well known, also with all the constraints possible, while with additive, the challenge was understanding what the limits are and how far we can push. So this was the challenge that we had to take. We did a lot of testing, also in collaboration with HP. We understood how far we can push in terms of static, fatigue, time, durability, crash. So the bot right now can take and transport a weight of 35 kilos, and this is our target. And the bots should be able to operate in different temperatures. So this is also a potential constraint. So they can move in hot environment, cold environment, and we know that the material properties can change. So this is a potential challenge that we had and we have been working on. So compared to traditional manufacturing, yes, there is less knowledge in terms of how much we can push the material. But in terms of course, the price was very high. So if we could achieve that, then we could unlock a lot of freedom in terms of volume. And last thing, while we optimize the bot and reducing the weight, we also have been optimizing the grid. So at the same time, we made the grid lighter. So we completely changed, because the bot design changed, we completely changed the design of the grid itself, where the platform where the bot moves. So it unlocked different scenarios for lightweighting in general.
Yeah. Allow me one question, because you mentioned the cooperation with HP. Has there been like a pre-phase where you were first starting testing additive in terms of creating spare parts for the bots, etc., before you said, hey, let's do the whole bot? Was there like a phase where you first started?
Well, we explored different technologies. We were fully open to understand what would be the best fit for us. We tried different technologies. We printed different parts with different technologies, but our goal was to use additive as much as possible because we wanted to explore this space. So in the end, we chose HP because it was the best fit for our needs in terms of printing capabilities, fast printing, and also material properties that we were interested in. So
very good.
That was.
And as we are discussing business cases today, sorry for that, I studied economics. That's always, if you come with a business case, you have to get challenged. So, asking your management, I mean, you're coming as an engineer, and I think you are quite fascinated of additive manufacturing quite easily, isn't it? So, but there are managers that want to see a business impact out of it. So if you say we are going from the 500S to the 600S with today's properties, is there a business case behind? So is there really a cost saving, not only a weight saving or an efficiency saving? What is the business case behind?
Well, yeah, the weight saving, including being able to operate with lighter batteries, with potentially faster operations and lighter grid, everything translates into cheaper infrastructures for us and also for the customers who will buy the platform.
Yeah, but then the next question would be, I mean, we're still talking about additive, so, and we're talking about the amount of numbers we tried to calculate at the beginning of our Q&A. So can you achieve with additive manufacturing the amount of bots you need in the future, if this is fully
We hope so.
Yeah, that is the plan.
We hope so. That would be a task for HP then to provide that, right? Yeah, awesome. Great presentation. Thank you so much. It is an awesome business case. I love it. And I can just recommend visit Okada, the webpage, because it's explained there perfectly. So you explain the whole process behind. And you can see it in action. And believe me, you have to see additive in action. That's what it's all about. So thank you very much. It was a pleasure to have you here. Big applause again.
Thank you.
Thank you.
So, ladies and gentlemen, you will of course enjoy a little bit of highlights, and then we have 2 more highlights to come for you today beside our after-work talk, of course. So stay tuned. Before you leave now and enjoy our highlights, please do not forget the voting for the Formnext Award is only open until tomorrow, 12 p.m. So please do your voting, because it's important for our startups and the Formnext, so you're supporting us a lot. Thank you so much. See you in a few minutes.
Welcome to Bosch Advanced Ceramics. Let's be innovative together.
Bosch Advanced Ceramics is a leading contract manufacturer in additive manufacturing of ceramics. Additive manufacturing of ceramics brings new benefits to the customer in terms of design, because previously with conventional technologies, the design was very limited, and now new possibilities open up. I would like to talk about the terminal head, a part that is used in the industrial application and that we're already producing in series production, right around 8,000 parts right now. The most important feature are the material properties of that part, because it's used in industrial applications, so the material properties have to be on the same level as the customer is used with conventional manufacturing.
There are many industries who are already leveraging the benefits of advanced ceramics. To name a few, semiconductor, medical are the early adapters for this technology. And the reasons why they are doing it is high requirements on the products. And they are making good use of this technology.
Bosch Advanced Ceramics is having decades of experience in manufacturing of ceramics, and we're leveraging that experience to additive manufacturing of ceramics. And we're already having 10 years of experience working in that field.
It's a very innovative technology because it brings benefits of sustainability with it. This means that the customers, they can reduce their time to market, and also we are using only as much material what is really needed, and having long-term experience in additive manufacturing for almost a decade, we are the right partners when it comes to the series production.
We accompany our customers along the whole process chain, from material selection to the final ceramic part. Visit us at boschadvancedceramics.com.
Hello and welcome back here to our program on the industry stage at the Formnext 2024 in Hall 11 and at the live streams at home. When you're considering additive manufacturing as a solution or probably a way to optimize your production, the thing is that companies often focus on challenges that have already been streamlined or even solved. So thinking outside the box, reimagining processes entirely with AM, that can be really, really difficult. And I think we can all agree on that, right? So, of course, on a day where we talk about success stories, we invited a person that probably can solve this problem and has a new approach about to challenge this issue with finding the right approach to AM. Our next speaker, Philipp Süß, is an owner of an engineering office, and he will present us an approach to solve that issue. And therefore, I'm very happy to have Philipp here on stage, and he brought something with him. Philipp, great to have you.
Thank you. Welcome. Welcome at Formnext. Many of you might have had the same experience that I had when I first saw an additive manufacturing machine. Maybe even today here at Formnext. I remember that day very, very well. It was about 15 years ago. I first saw an additive manufacturing machine at our hometown university. and I was mind blown. I knew this is something new. Here, a new era has started. From that moment, I focused my whole career on making sure that additive manufacturing is actually applied effectively in industrial applications. However, over the years, I quickly learned it isn't that easy. Especially deciding where that technology is the right technology for the job and where it is not can be quite challenging. Let me quickly introduce myself. My name is Philipp Süß, founder of Süß & Friends. After working in research on developing new material models for additive manufacturing to make sure the parts actually perform like intended, or developing post-processing mechanisms to ensure high-quality surfaces within internal fluid chambers, I changed into the industry. I worked many years in the automotive industry to bring additive manufacturing into that technology, into automotive. However, after a few years, I noticed it is always difficult. Matching the technology to the right job seems to be quite a challenge. And that not only for the big companies, even more for the small ones. That is why I founded Süß & Friends, together with two colleagues, Tim and Timothy, in 2017. We are a small team of additive manufacturing engineers. And what we do is pretty simple. We guide companies on their journey to decide first, is additive manufacturing the right technology for us? And then as engineers, produce the parts. And more so, develop the parts to be produced on the machines of our customers. Many of the parts we designed are now in continuous production for more than 6 or 7 years. Some of them I have with me and I want to show you soon. Quickly, let me say what we do differently than many other in the industry. I believe that engineering is key. Finding the right application, thinking differently, and creating new products for serial applications is key if you want to use the technology. This is why I decided early on to be independent. We don't sell machines, we don't sell materials or software, we design parts, and this way we can say no. Saying no, in my experience, is the most important word in additive manufacturing. Too often this technology is pushed in applications where this simply isn't the right choice. We specialized. Focus on additive manufacturing means we can actually make uses of the technology for its best. And that means we say no to customers that simply are not the right fit. And then maybe the most important one, value creation. Additive manufacturing is not a toy, it's a tool. And it doesn't lead to profit. If it doesn't lead to value, then we simply shouldn't do it. We're called Süß & Friends because we think that in the end we need to work together with other experts to create a full process cycle. Also, we don't sell machines. We guide you through the process of deciding what is right for you, what are the processes needed after the machine, and how to actually build the trust and the knowledge and in your company, within the people, and making sure they apply the technology effectively. It's often said that additive manufacturing is unique, but why is that? I always summarize that on 3 main points. First, in additive manufacturing, we don't need tools. We don't need the initial investment in new tools before we start production. Second, without that initial investment in tools, without the time needed to produce tools and production setup, we are faster. And that leads to high availability and resilience in production. And third, and that's sometimes a little difficult to understand for many people, in additive manufacturing, we can create very complex geometries without an increase of cost. And that means we can take a lot of different parts and functions, put them in a single part without creating additional costs. I said before, I don't think additive manufacturing is a toy, it's a tool. So how do we actually turn additive manufacturing in a production technology? Let's compare to injection molding. I always like to show this graph. What we see here is the cost per part as it changes with the parts produced. In technologies like injection molding, we usually have a very high initial cost for producing of the tool, making the tool, and then we have a steep drop-off. In additive manufacturing, that's not the case. Without the initial investment in tools, we can start much easier. The break-even point is on the low quantity side of production. Some of you might wonder why the blue line is named AM as production alternative. The comparison we here see is one that is often made, and that is comparing additive manufacturing to another technology. Here we have an injection molded part that is designed for injection molding, designed for the injection molding process. However, in certain situations, it is very valuable to have a production alternative, especially in early production. That is prototyping. Prototyping is nothing else than having a production alternative. That is ramp-up production, where you don't have the complete production set up for injection molding yet, or end-of-life parts and spare parts. All these are examples where additive manufacturing is a production alternative for a known production technology. Let me give you a quick example what I mean by that. We have a customer that maintains public facilities, parks and recreational areas, and they operate many pumps. And one of these pumps was not longer available, but this part broke. This simple cover of a pump housing, and that meant that they had to replace the whole pump system. Instead, with additive manufacturing, we were able to replace the part and thereby extend the lifetime of the pump. That was 5 years ago, and that means this single pump is now and has now an extended lifetime of 5 years. This is an example how with additive manufacturing we can reduce downtimes in production, extend our lifetimes of production machines, and in general react quickly. But this is an example where we used additive manufacturing as an alternative for another production technology. The original part was injection molded, but for different reasons, the mold and the production process was no longer available. And here we used additive manufacturing as an alternative. And that is very great. However, not all parts can be produced with additive manufacturing. And this is why we often need a design optimization process. Design optimization means that we take the part and make it better printable. We design it in such a way that we use less post-processing and that we overall lower the costs. Here it was simply adding a surface so that we don't need support structures. We also changed the material. This is a fiber-reinforced PA. But I want to make very clear, we have AM as a production alternative, and we can make the use cases much bigger by design optimization. Here we still compare a traditional produced product with injection molding to a production alternative. Now, what happens if we think differently? What happens if we go away from the existing part in our mind and take additive manufacturing into our mindset as a prime first production technology we want to use? Then this happens. By changing the mindset and producing parts to be designing parts in such a way that they are produced for additive manufacturing, we can lower the line and make additive manufacturing actually the best tool for the job. This is what we do. This is what we can see at Formnext in a lot of examples. These are often these heat exchangers that are the gas turbines or rocket parts, but it doesn't always have complicated. I want to give you a simpler example. We have a customer that operates and maintains these water ski parks. This is basically a ski lift on the water. And what we have here is a very traditional part designed in the 1970s, like you can see in any machine shop. Very simple function. This is the end of the rope that the person hangs onto. The rope is grabbed, transported to another location, and then released by spring load. They came to us with the idea to reduce the wear and tear. As you can imagine, we have a lot of wear and tear by two metal parts on another. But then we did something we always do, and that is step back, zoom out, and see what the actual problem is. And what we saw here, we have a very traditional designed part, how it's done in subtractive machining. These are many different components welded together with a lot of production steps. And what we did then is think, how can we do it differently? How can we design the part actually around the functionality? And this is the result. We have a traditional metal part replaced with a single additive manufactured component, thereby reducing the number of production steps. That is a big cost saver, reducing production steps. We also reduce the number of parts as well. Let me add here, we still kept some simple machined aluminum parts at the back, but overall there was a great cost saver by reducing the number of parts. However, the biggest advantage here is weight reduction, and not just by a few percent, but going from over 400 to under 100. Now, I said a few times now that we need to think differently, that we need to approach engineering differently. How do we do that? Well, I made the distinction between using additive manufacturing as a production alternative and using additive manufacturing for new progressive parts. These are two completely different approaches. The problem we often see is that companies who want to start in additive manufacturing, who might have some first experiences in prototyping and now want to move into actual production, they look at their existing part library, the iceberg that is visible, and do part screening on what part could be additive manufactured. However, here the outcome is very limited. Looking in your existing parts and finding parts to be additive manufactured will not really get good results. These parts are proven, your employees know they work, and they are already designed for the job they do. However, finding the unknown, thinking different ways, and creating new products in the future with additive manufacturing is quite much more challenging. There we need a bottom-up approach. That means building knowledge, shifting the mindset within the company, and creating new techniques to actually think differently in order to make additive manufacturing happen. This is the bottom-up approach. This is the innovative approach. But innovation is often easier said than done. So we asked ourselves many years ago, is there a method to innovate? How can we create structure to innovate, to create new products for additive manufacturing? There is no golden rule, but over the years we have found quite a good setup that I want to share with you, and maybe you can take some of that home to find new products in your own company. The first, and that is what many people do, is we create a moderated innovation team. And here I want to emphasize the moderated part. Creating a team to innovate, that's what many people start, or many companies start with. A team with different skill sets. However, in order for them to actually find new applications, they need someone who can moderate them, who knows additive manufacturing, who knows how to ask the right questions, who knows where the problems are, and steers them in the right direction. Now, an innovation team still needs to work together. They need a methodology. They need a way to work. Otherwise, it will just be another workload on the pile to do. We use something that's called the Walt Disney method. That basically means we divide the whole process into 3 phases. The first is the dreamer phase, and this is because we often experience that with using additive manufacturing, especially if you're in very conservative businesses or conservative industries, people are very critical. They say we have always done it the way, we don't want to change. There are these and those and that problems. So that's why we start with the dreamer phase. There it's not allowed to critique, there it's not allowed to actually work on the solution. That's where we create new ideas how additive manufacturing might be used and how we get creative input. In the second phase, we turn that into reality. That means we create concepts, we start designing and turning these rough ideas into something that is tangible. And then, most importantly, the third phase is the critic phase. We need to evaluate if it's viable, if it's economical viable, if we have problems with materials, if we have some restrictions, if we have certification, all that is in the third phase. We do this in an iterative process and collect all the information in concept fact sheets. And the reason is simple. Having the new concepts for additive products on an evaluation sheet gives us the tool to evaluate and sort them and give them a rating. We usually sort them in 3 groups. And the first one, the most important one, is the one on the right, the one we discard. Many people, especially when they want to sell machines, tell you where the good opportunities are. However, it's much more important to know where they are not. Having an answer on which parts not to do, where not to waste energy, and where not to waste budget is very important. And then we usually have on the right side the ones where we think, okay, these are projects that actually should be done, where we should clear a budget. And the whole aim of that is creating decision proposals. In the end, we need someone to sign off on start product development, and that is why they need all the information needed. The decision proposal is not only the idea and the concept, this is also a cost estimate, this is a roadmap on how to be done, this is a risk assessment and many other things. And then we can go to the decision makers and say, okay, we want to take this and this and this project and turn it into reality, we need this budget. I want to give a little quick example on how that can be done. We had a customer that do produce lab equipment. Very complicated, different machines, highly detailed, high precision needed, and a lot of restrictions in the industry. And what they wanted is make the process better for the people working with the lab equipment. And this is when we formed that innovation group with some of the lab workers, with their support managers and salespeople and engineers, and came up with new ideas how can we make their processes better. And the result is to create a system of sample preparation tubes that can be used to more effectively handle samples within a whole system and make sure that all samples are digitalized and accounted for correctly and all samples are measured. This is a typical application for additive manufacturing because we have small quantities, we have very high precision needed, and we are an industry here in laboratory equipment where we have very high specifications. This was a quick overview on a way that we use to actually get new application into reality. I know that it can sometimes be hard. This is why I've prepared on our website some of the use cases we have. I would like to invite you to come talk to us. Maybe you want someone who can help you along the way. This is what we do, help companies on the way into additive manufacturing. Me and my colleagues are here today. Tim and Timothy are standing on the side of the stage also. And now, are there any questions?
Thank you so much, Philip. Awesome. Big applause, ladies and gentlemen, for Philip. I do have a question, Philip.
Sure.
Sorry for that. But first of all, the audience, any questions from your side? Okay, let me ask you my question. I was really positively surprised about the process you presented. But I tell you what, I'm doing a lot of lean management consultancy, and this is where you train the people thinking outside the box and start following a method of problem solution or root cause analysis, whatever that is. And it's a pretty similar process in terms of it starts with a good moderation, etc. So if I explain this to very technical-oriented people, you can see in their eyes that their reaction is like, Guy, we wanted to have a method. You know what I mean? So they don't consider that as a method. What are your experience on that?
Well, my experience is a little differently. What we actually do is empower people to do it themselves. We don't want to do it for them. We want to help them, empower them to do that themselves. And that method helps to make the conversation between the different people involved. And what we always experience that people are very skeptical of using innovation methods at all. Yeah. I mean, we talk to a lot of very conservative people who have worked with the machining or on the workbench.
That's what I mean.
Heavy metal parts all the time, and they say, "Oh, don't come in with that. I want to work and want to get it done." And this is exactly why I divide it into these 3 phases, so that we can basically move the skepticism back to a later stage, after which we have already created the first solutions.
Yeah.
And another thing that's always good, start small, give them first great examples to actually solve their own problems, and then you go step by step from there.
That's an important point. So if you start with them the process, how difficult is it to get them out of their, let's call it, how do we call it? That's a good question. Let's call it traditional thinking.
Okay.
So how difficult is that? So usually coming up with, we thought about that. That would be the solution.
No, that's exactly the wrong thing to do. If we as outsiders go there and say, this is what you need to do, the project will fail, almost guaranteed.
Yeah.
We need to empower the people and to give them the tools to actually solve the problem themselves. And what we found is, ask question, where are your problems at the moment? What are you struggling with? What is the thing you want to change in your daily work, in your, whatever it is, an assembly process? And from there we can see, okay, here we might go in and actually help you make your job easier, make your job better, and your life in your company better. And this can be little things. We can start with a holder, a tool, a guide to drill the hole at the right place. These are the things we usually start with. And then you can build very quickly from there, but after you have gained the trust for the technology.
Now you are an AM enthusiast, so
definitely,
which makes it sometimes, of course, more difficult to be neutral. So have there been cases where you needed to say, hey guys, listen, let's do it the traditional way. The way you're doing it is fine. Optimize the process, whatever. Is that sometimes the case where you say, I don't think AM will help you?
This is the most important word in my vocabulary. Louis is saying no.
Yeah.
We are often asked or consulted by companies who are unsure yet if additive manufacturing is the right tool for them. And we took the strategic decisions to not sell machines, to not sell the parts, to not sell software. Simply to be able and be in the position to say no. And we do that often and a lot. Yeah. We actually turn the process around quite a lot of times, meaning we actually want them to say no. We want them to say 4 times to additive manufacturing. And then when we have a yes, it's a clear yes, and you can work with it and actually make great things happen.
Very good, very good. Philip, excellent presentation. You convinced me, at least. I mean, this is for sure. I don't know the others. Have you convinced you? A quick survey here. And so raise your hands if you are convinced now. It's not the majority so far, but
we will change that.
Thank you so much, Philip. It was a pleasure. I will see you in a few minutes, basically, in our panel discussion. Okay.
Looking forward to.
See you there. Thank you so much. Big applause, ladies and gentlemen. Phil Süß. Yeah, ladies and gentlemen, we will provide you, of course, with some more highlights. And I don't think it's the last time I will say that today, but please don't forget to vote for Formnext Awards. The colleagues are so kind to giving you the QR code to do so. And stay tuned in our program, because in just a few minutes, we will have an amazing panel and we will discuss real business cases and real things to observe in additive manufacturing. So stay tuned. See you in a couple of minutes.
I
There's dirt on my hands, strong like a tree. There's roots where I stand. Oh, I've been running from the law. Hope they won't shoot me down soon. They sing on a sleepless night. Try to catch me howling at the moon. Won't stop fighting to the very end. Many men try to reach it, many men have failed. Well, if you wanna get to heaven, you gotta raise a little hell. And I've been running from the law. Will you find me? Hope you find me. I'll be back home soon. When the sun rises, when the sun
At UPM Additive Solutions, we are a global supply chain provider that focuses on conventional manufacturing, specifically subtractive, to provide tooling and consumables to the additive industry. We use subtractive manufacturing to produce build plates and recoater blades in various alloys, whether to OEM specs or to your unique additive needs. We also offer the full supply chain solution services such as heat treatment all the way through to testing of the part itself and everything in between.
Yeah, what we're most excited about this year is our new product service offerings. Since we started this branch of United Performance Metals, we started with new and refurbished build plates. Since then, we've been able to add powder supply, feedstock supply options, and even post-print processing.
Our customers really benefit from our services because we manage the entire process but the print. This allows them to focus on their value add, and that is designing exceptional parts, printing them, and scaling their production while we do the rest.
Please don't hesitate to reach out. We're excited to collaborate with you and see what solutions we can find to your supply chain problems.
Hello and welcome back, ladies and gentlemen, here to our panel, Business Cases, Real-World Successes and Collaborative Insights into AM. Yeah, definitely. I mean, we just had the last speech about that. So additive manufacturing isn't just about technology, and that's very important to know. It's about creating value, solving challenges, and driving innovation. And last but not least, don't get me wrong, in any certain way, make money or reduce costs, basically. That is what you can see at any booth here in the advertising, in the claims, but let's be honest, we far too rarely take the time and evaluate the real impact of the solution we are seeing. Today's panel session will be different because we will focus on real-world business cases that will demonstrate how AM can transform industries, create probably new opportunities, and spark successful collaborations. So, from enabling entirely new business models to enhancing existing operations, this discussion that will follow will highlight the stories behind the successes. So, and I'm super excited to have the discussion. And of course, we brought together quite a lineup in terms of experts, and I'm super happy to welcome them now on stage. So, here we have Dr. Gerd Klaas, who's project manager AM at Cyrus. Cyrus is correct, by the way, Gerd? Or?
Cyrus.
Cyrus, very good. And you're responsible for the 3D OP project, where we are talking a little bit about. Then we have Alexander Schmöckel. Good to have you, Alex, here.
Thanks.
So you are associate at AM Ventures, so I'm pretty glad to have you on stage, honestly. Then we have Andreas Schultheis. Very good that you made it. CEO and founder of Schultheis and Rapid Shade GmbH. Very good to have you. And to my left, you already know this guy because he just presented before, Philipp Süß, owner of the engineering office. How do you say that? Engineering bureau in English? I don't know.
Office is good.
Yeah. Süß and friends, it's good to have you all here. Philipp, we need to start with you because you just had your speech. So you focus on strategic consulting, as we just heard in additive manufacturing.
Well, I actually don't like that term very much.
Okay,
We're engineers
explain.
at heart, we create products, and consulting is something that needs to be done often along the way.
Yeah, so we were talking about, or you were talking about the method you just, let's call it invented or developed. So can you talk about a super cool business case where this method was applied and finally we had a good success story behind it?
There's always one that comes to my mind. We had a customer that the company is called Wakesys. They produce software. They make point-of-sale software and booking software for sports venues. And what they realized over the years, the customer actually doesn't want to buy a software. They want a solution.
Yeah.
And with sports venues, it's always difficult to automate the process. So what they thought, or what we did think with them, is how we can change the business model with additive manufacturing. So what we basically did is create different points of interaction for the customers, for the users, where they interact with the software, but not through a computer, but through a chip that they have on their wristband, and then they can book their parking in before they visit the spot. They can buy their beer and get their locker closed and open, and all points where the customer actually has interaction. We put little devices, reader, all different, and that would never have been possible with traditional methods. We needed like 6 different housings for different reader modules, and this was done by additive manufacturing. And the great thing about that is here we took a traditional software company that were then able to transform their business model to an end-to-end solutions.
Yeah,
so away from the actual base business and be much closer to the customer and listen to the customer and actually get an end-to-end solution. And here additive manufacturing was just a tool. It wasn't too big, but it actually made big changes in the business itself.
That's basically changing their whole business model, basically, isn't it?
Exactly.
Great, awesome. Gerd, and Cyrus, focus, research and innovation, is that correct? I mean, I would say so, yeah. how do you ensure, I mean, if we're talking about research and innovation, we often come up with those fancy ideas and additive, and it's so easy, even if as an external, I promise you, super easy to have creative ideas. I remember when I first told Arno I want individualized handy cases, and he laughed at me. So how do you ensure that the developments you are doing in AM are practically applicable for businesses? Because in the end, it's about business.
First, I need to explain what CIRIS is. It's our innovation center, actually created by the industry and serving the industry. So we actually have over 2,000 companies in Belgium, which are our customers. And we want to help them putting the next step into their processes in terms of innovation and having better efficiency, etc. A part of it is AM. And for AM, it's a challenge. It creates expectations. But because we know the end user, we can guide them in the process. We educate them what is possible, what not. We try to understand their value proposition, what they need, what they want to achieve. And we guide them step by step by making a business case or even developing a product and then transferring all technologies. So we guide them, close communication, and really keeping the expectations realistic. That's key, of course, in the story.
Is it sometimes demotivating for the partner then when you say, hey, listen, I mean, it's good to have a good imagination, but it's not feasible?
It's like Philip said, sometimes you need to say no in order to take the next step forward, because if you start with the expectation which is too high, then it's a recipe for disaster. So saying no and then building step by step the trust that we know the landscape, and we can tell them which step to take, which provider to contact, which technology is best suitable, and then from there we continue and we build a relationship and we build a successful future for the company.
So as a first takeaway, we can say it's important to have the right collaboration and the right partners in order to implement it in any way, basically. Right. Andreas, good to have you here. So you worked
Thank you for having me.
Yeah, great. You worked extensively in both traditional and additive manufacturing, which makes, I believe, sometimes makes it more difficult. So from your perspective, what makes a business case for AM truly successful? What would be success for you? Is it more like technology, application, or partnerships involved?
I mean, maybe to come to the answer, I explain a little bit also the background about where I'm working before. So I'm working in Schultheiss GmbH, which is the business that my parents actually started in the 80s. I mean, it's about casting. It's about gold and silver casting. It's about the jewelry industry. Making a lot of nice smiles to girls and to boys. And this is a super traditional industry. I mean, it has been made for thousands of years, so that you just melt up a metal and you're casting it into a negative mold. Right? And then in 2011, I started RapidShape as a company. And now the question is, how do they interlink? And I think this is already a part of the answer, isn't it?
Yeah.
So it's not, AM is not a purpose. Definitely not. So you need to pick the right process steps in order to make them in additive manufacturing or keep traditional methods. And at the end, you just select whatever works best in order to work most effective, most fast, to the needs of the customers. I mean, if I stay, we are doing much more than jewelry. We are mostly in dental today, making patient individual parts. And I mean, all of our teeth are different. By the way, all of our ears are also different, also a segment that we work in. And jewelry, there's a January design, there is a February design. And by the way, we have different ring sizes, isn't it?
Yeah.
So there's a lot of different designs that you have to produce. And this is where additive manufacturing can be of benefit to make something very individual, very fast.
So basically, if I understand you correctly, it's also very important to have the customer demand, which results then in a solution that fits better, and this is probably based on additive manufacturing.
Absolutely.
Very good, very good. Alex, I won't ask about your magician skills.
Only by night.
I promise that, but you are around the world, and I know how much you're traveling, scouting and evaluating new technologies in a very early stage. So sometimes, you don't even understand it, or your colleagues don't even understand. You need to get it explained. So how do you see startups in AM impacting traditional industries? Because I know that in your portfolio you have some really quite successful AM startup. How did they change the industry, and what were the success factors?
I think
it's if you look into traditional industries, it's really okay. What problems do they currently have? And I think most of the time, if it's maybe just one component, they change and switch to additive, but suddenly you have a huge impact, a huge efficiency gain. So really about high performance parts. But if you look at the overall value chain, you have maybe only 3D% of the value chain is printed and additively manufactured. And you even are utilizing adjacent technologies, and that's also a key point I want to make. Don't see it isolated. I mean, it's just additive manufacturing is just a toolbox, and I think traditional industries, indeed, where it's really about efficiency, but at the same time, this whole DFAM thing, right? You can even create entirely new markets with it. Because per definition, you are not stuck to the old processes and you are more open and start from scratch. And we have seen it in the new space economy. We have seen it digitizing the whole orthodontic space with one of our portfolio companies, Lightforce Orthodontics, digitizing the entire workflow and utilizing ceramic 3D printing to shorten the patient plan, the treatment plan for the patient in the end.
Yeah. Is it sometimes, Philip, when you listen to what Alex is saying, is it sometimes AM? It always is only a small portion of the whole thing, like it's pretty similar to the software example. So, but is it, as in your example, sometimes the key in order to just open an opportunity, which would not be feasible without AM?
Yes, that's one part of the puzzle. Getting new opportunities and from there creating new business models. However, I experience, and maybe that's your experience as well, that the industry is always very technology focused. Yeah. But in the end, it's about the people, it's about creating something. And we come from a time where additive manufacturing is very brightly advertised. The advantages are advertised, but turning that actually into a transformation of a business and actually finding use cases is quite difficult often. And I think, quite honestly, that's the wrong approach. It's like having a hammer and then finding the nail. So if you don't have the problem, you don't need the tool.
Yeah, so true.
What I see is, just when I look into my laboratory customers in the dental space, and we have in the meanwhile, we have more than 5,000 customers in the dental laboratory space. And we do have the early adopters, because the technology is there. You can print that case, you can do it. But not everybody is changing right immediate and spotting it and taking the advantage of it. So it's really about changing mindsets as well and being open to new technology. And then I think also what is very important is that even when you are a process engineer, to be open that there is some change in your process happening. And we have had so many cases where we came in with a solution, proved to be in spec from the side of dimensions, proved to be in cost in spec, so commercially in spec, faster sometimes, but still maybe the color was not the right one.
Yeah.
Or some other argument, and then at the end you just don't realize it immediately. So it's also about really also managing people, moving one step forward.
Mm-hmm. One question, Gerd, to you. So let's talk a little bit about 3DOP. Probably you can introduce us to that project a little bit, and then we see where the connection is to our topic here today.
Okay, so Ceres is part of the steering committee of the 3DOP project. It's a big European i3 project funded by the EU. It's 10 million euros around funding. And it's 33 European companies spread over Germany, Netherlands, Belgium, Slovenia, Spain, Italy. So quite diverse, quite a big consortium. Mm-hmm. And it's actually focused on 3 big workflows. And the big aim is to use recycled materials to print, but also focusing on automation and quality control. One of the partners is AMflow, for example, who are focusing on really making automation tools for AM. And there the success is that we have the entire value chain, we have the material suppliers, we have the end users, we have inspection tools like Hexagon, Siux is in there, AMflow are building the total solution, and the end users like Fibo Dental in Spain. They have a real application need, they want to automate their workflow, and their big steps are being taken there because everybody's in the consortium, everybody's working together. But the big challenge is, of course, it's a big consortium. Communication is key, and also setting expectations and keeping the short communication lines and adapting, because it's an innovation project. As you know, innovation, it's not that it's there tomorrow. No, it's you do something, you hit the wall, and you start again. And that's what is happening in the project. We're making big progress. And actually, you can look at it, 3dop.eu, the website. And next year is actually more on spreading the news of what is happening in the project and expanding the network and finding funds to do new projects together with more companies. And that's why we also have an open call now to actually collaborate with SMEs all over Europe with the companies, the partners we have in the project. So.
Let's talk in this context a little bit about collaboration. So for each of you, where have you seen success stories that were based on collaboration? And I'm pretty sure that's nearly all the time the case. But Gerd, can you mention one?
Yeah, in the 3DOP project, I already mentioned the case with AM Flow. Yeah. For them, the big benefit is that each component in their flow is part of the project, so they have their short line of feedback, they develop something, they can test it on the flow of the end user, and then they can adapt, they make short adaptations and short iterations to have a successful project. So there, and then also, of course, making great, let's say, agreements before you start on whose IP you're going to work on. Because who is the owner of the IP, that's also a big problem in projects. And there you need to make good agreements from the start. Yeah. That's also what we do with Ceres. We work always with companies who have a need. They have a problem, we solve the problem, but the IP is always for the customer. Yeah. Unless, of course, it's something we develop in-house and it's not based on a real problem from a customer. It's our IP, but otherwise the IP stays at the customer. So.
Alex, that brings me to you directly. I mean, having the IP and collaborate, this is like contradictory sometimes, isn't it? Because, I mean, you're working together. Who was the one who brought finally the idea into it? I mean, I know Aimflow very well, and I mean, they try to revolutionize the post-processing and automate, which is one of the key success factors right now. But let's say they collaborate with the one that is producing up front and they get together. Who's the product owner, Alex? I mean, that makes it difficult for you sometimes probably to connect your portfolio partners because you need to figure out who's the owner of the whole thing, isn't it?
Yeah, I think IP is a big thing for us, and we obviously want to know who owns the IP, especially with university spin-outs. Yeah. I mean, for the collaboration, what is crucial is that you have a clear understanding and the right expectations that are set and even distributed commitment to the project. And there are certain ways to work around it, and also who knows who's the product owner, because in the end, you cannot do it on your own. Like right now, they evolve doing 3D printed filtration membranes, and they have the application know-how, and they are searching for this technology that can only solve this problem, and that's why they don't want to use it as a bridge manufacturing solution, but really know, okay, it's where AM creates the most value and is solving the whole customer problem.
So for them, it's difficult to find a partner due to IP reasons, or?
No, not difficult to find the partners, but I mean, they found it in the end because the necessity was the technology. IP can be also from a business perspective said, okay, license, and there are certain ways to get royalty payments and even all that stuff. But I mean, in the end, if you collaborate and there's a benefit, it has to be also certainly distributed that everyone gets an equal portion of it.
And what I often experience is in additive manufacturing, we often create something new. And that means we create new IP. And creating new IP that is maybe shared is better than having no in the first place. And that is something I believe we should focus more on.
Yeah.
We have an additional aspect. You're focusing a lot of IP creation and additive manufacturing, but there is also an aspect of going to the customers. So because there's those very innovative companies making additive technology, making software and whatsoever, but then you also need to have the distribution partners which have the trust maybe generated over decades. For example, in the dental industry, there is dental distribution partners which have very well connections and which actually translate what we do in that high-tech world, and they translate it to the language needed in a certain industry. And then what I have understood is that in every additive manufacturing technology, you have equipment, you have material, and you have software, you have post-process. And it's very hard. I mean, we are coming from a situation where there was one company providing everything, but today I think there is more collaborations. And by the way, also Formnext here is a huge place of collaboration. So when I'm here on the exhibition, I do have a lot of talks only about collaborating more in one or the other aspect.
Yeah.
So it is very important.
Let's talk about defining success for a moment, because when I prepared for this panel discussion, I was like, yeah, we're talking about successful business cases, but what is a successful business case? Is a successful business case we solved something, solution-based?
No.
Is it something that has to do with the economic outcome? So did we earn money? Or is it, a new collaboration? What is success, in your opinion? Gerd, what would you define as success?
It can go all ways. It depends on the case and it depends on the company. But yeah, success stories. For example, you have printed furniture which goes into airplanes, where we have actually less weight, you save a lot of fuel. That's a success story because we actually have environmental impact. So it can be bigger than that.
But if it's not bought by the airlines or by the... then that's was true. Fantastic. And that's, don't get me wrong, probably, Alex, looking into your portfolio, I mean, we were discussing the sustainability thing, and that was something AM Ventures was, or is still pushing very hard. We're looking at, there is a sustainability impact, a high one, but it's not economic-wise, let's call it appreciated, or not, what kind of issues there? What would you define as a success, beside the...
I mean, it's always good to start with the terminology and have a common understanding of a business case, because we are approached by so many founders that are talking so many about the technical enablers, but are not able to quantify it in an economic point of view. Because in the end, a business case is a clear explanation of why this project investment is a good idea, including all the costs, the benefits, the risk associated with it, but really in the end, obviously, because I'm working for a venture capital firm, prove me how this can be potentially my fund returner and show me the return on investment. So it's indeed more about the business object, because in the end you have always business goals, the company you're working for, and also the startup. So I always try to, give me the numbers and try to quantify the business case and give me the clear triangulation of the market, because don't compare yourself with the additive manufacturing market. If you are developing an application, I want to understand the vertical and have a proper understanding of the market you are addressing by triangulating it in a correct manner.
And how often there's a misunderstanding in terms of what success is?
A lot. I mean,
I would say about 90%, isn't it?
Yes. I mean, I'm also an additive manufacturing enthusiast since 2017, and I find it cool, and it's such a cool tech. And also when we are approached by founders, they are saying, hey, it's so cool, finally I can talk to a venture capital firm that understands the technology. But in the end, no, I said, it's wrong. You have to tell it and tell the business case to your niece, to your nephew, to your grandma. And if they understand, everyone else will understand, and you will be able to fund follow-on rounds. So.
Right. And then, what was pushing you to go into Rapid Shape? I mean, there was kind of a motivation, and please don't tell me you wanted to try out a new technology.
No, definitely.
Probably yes, I don't know.
Yeah. No, definitely not. You saw me smiling. So definitely it's always related to business. So at the end you need to make business with it, so it needs to be profitable. Rapid Shape is a profitable company since many, many years. I think this is essential that there is something in for the pocket of your customer, so making it having a bigger share of wallet for him, but also for the manufacturers. So what drove us in the beginning was actually very interesting, because I am living in Germany in an area where we are close to a city which is called the Golden City, and I mentioned before that we are coming from the jewelry industry. So it's about Pforzheim, and in Pforzheim, there's a lot of gold, there is a lot of jewelry manufacturers. So, and actually in the 90s, it's going back to that time in the 90s, a lot of companies suddenly closed down their manufacturing sites and opened huge manufacturing sites in Turkey and in Thailand. So it was just too expensive to manufacture in Germany. And actually, it was my father at that time who said, how can we provide a tool to make it viable, to make it economically interesting, to produce something wherever you are, so decentralized. And actually, this was the first idea of driving us to provide technology, which is a very economic, a very efficient tool, helping the customers wherever they are. And this was the initial idea of bringing us into the industry. But then for every single business case, I'm calling it already business case, sorry, I'm very influenced by you at the moment. No, for every single application that we are driving, we are having a total cost of ownership calculation, and then there is the traditional method, and then there is the additive manufacturing technology. Then we are comparing various additive manufacturing technologies, and only if we are the most economical one in spec, then we can deliver to the customer. Only then it is the case.
Yeah. Talking about the customer, it's serious. If you build up like 3DOP, the initiatives, if you go into that, is it more about driving the technology or the industry overall, or create real applications as well for, let's call it end user? I'm not talking about B2C, but...
Most of the time, the projects which we run for our customers are focused on the customers and are really applications.
Yeah.
But indeed, the challenge is the return on investment. What is the total cost? And how can I make money? Because it's not I buy a machine and I buy material and what comes out I can sell. No, you have post-processing, the machine time, you need to pay the gases, orientation of a part, removing supports. It's all these things which people are not aware of. So it's also educating, which we also do. We offer workshops to our customers to educate them what is all possible, and then assisting them in the business case, looking at the numbers, and then what is possible and what is not, and saying no, scratching what is not possible, because way too many people believe that everything is possible with AM, but you need to find...
I did for a long time, but yeah. So true.
It's, when I said that about, analyzing the total cost of ownership, definitely you need to see a little bit into the future. Because something which might be not being commercially viable today might be with research, but then it must be credible. It must not be something in the cloud, can become viable over time. So also it's the path which goes somewhere, but you need to understand when then there comes the break-even point. That's for sure.
Philip, you presented how to approach and a new innovation approach, or let's call it rather assessment approach. What is feasible, what is not. To what extent does this TCO, so total cost of ownership, play a role in this, or is it first of all the innovation that counts, the solution?
Total cost of ownership is the main factor.
Yeah.
Many people do still make the mistake to account their business case on the cost per part. However, in additive manufacturing, there's much more to think about. The advantages of additive manufacturing are often not in the production of the part itself, but in making a better production process overall. And this is very difficult to quantify. And we often have the challenge that we see companies, they evaluate how a part is produced in a conventional way, let's say by injection molding, and then go to a service provider and get the cost on what would that cost to produce 10 pieces of that with additive manufacturing, and then are disappointed because it doesn't match up. And there are two reasons. First of all, you need to look at the total cost of ownership, not only the single part, and then comparing a part that is designed for a conventional method and then transferred to additive manufacturing is usually not the best part to be printed in the first place.
Okay.
But that's the difference between total cost of ownership and just the manufacturing cost. So the total cost of ownership is at the end, you have a certain revenue about something. If you can sell it at a higher price, or if you can save on other parts of the processes, and this is exactly what you said, isn't it? Then at the end it makes sense. It's total it's not focused on that small niche.
Yeah, and
it's
I'm
total.
not sure whether they really have that perspective from time to time if they're considering additive manufacturing as a possible success story. I remember additive drives, for example, producing copper wires and for electric engines. I think sometimes the people they talk to don't even understood what they could save with their total cost of ownership. And sometimes they didn't know themselves, I had the impression. But this has changed totally. This was groundbreaking, basically. So this is one of the success stories, right, out of your portfolio?
Yes, indeed. Utilizing additive manufacturing to 3D print electric motors. But also there, they don't see it isolated, right? They see it as, hey, okay, I can utilize it, but I have adjacent technologies around that is creating the value. I think it's tough for them because if you talk to the procurement guys, they say like, okay, but in the end, I only care about this specific cost per part. I don't care because I have my payroll and I was hired for this specific reason, and this is really tough.
Yeah.
I remember my time at EOS when we tried to quantify the value add and see it really the TCO calculation. It's so hard to get it quantified because you say, yeah, we are maybe a little pricey, but we can reduce 80% of the cost. And then the procurement guy says, no, like I don't care, like I just prove me the reference.
He or she doesn't get a bonus for the cost. That's the thing. I mean, and we were coming out of a time, I don't know whether you know, like 10, 15 years ago, when you talk to procurement, they had a much broader view on the whole process, and I remember that was much more quality based than today. And today is really they're focused on the buying process and what do we have to pay for the solution, and they are sometimes not considering what the, let's say, the end user inside the company will benefit from, or even their end customer. So this makes it really difficult. But beside additive drives, Alex, can we share some success stories here in that round? I mean, from each and every one of you. I mean, we heard already a few, but as we have one success story here, thank you for being here. Yes.
I mean,
the ones you are allowed to talk about.
Yes. I mean, also a good proving that collaboration is a necessity in our industry is handmade materials, producing and selling polymer-coated metal feedstock that can be put onto SLS machines with the debinding and sintering process, so a sinter-based AM process. And for them, they are seeing really huge impact on where other maybe production technologies are not cost competitive in the impeller industry, which is having really can reduce a lot of energy costs in the end, has a huge impact, but really, other than that, excavator teeth. So where you think really, again, traditional industries where you think, okay, like why should they adopt it? And they have a huge bandwidth, what can be achieved. And the good part is they see it, hey, our strength is the material, but we need the sinter guys, we need some other, we need to sit on a table, and that's why they also implemented the Cold Metal Fusion Alliance in the end to really have the sinter association.
So it's also a collaboration that led to success, basically. Yeah. We are always talking about industrialization, and everybody will feel free to bring another success story up to the table, because this is what this panel is about. Talking about industrialization. Everybody's talking this year's Formnext about industrialization. And I mean, you mentioned AM Flow, and this was one of the major targets to be part of an automotive process and therefore get industrialization. Do we have it already, Philip?
I believe we as an industry need to be very clear that in the rarest cases, there's a finished product falling out at the end of a 3D printer. That simply doesn't happen. And for people new to the industry or looking at the industry, we need to be very clear that it's a complicated process. And industrialization means basically having control over this process and designing that process from the very first to the very end. And that is much easier said than done.
So your answer would be no. Yet.
In some industries, it's the case. They're creating medical implants which are certified, etc. But a lot of work is getting into the certification, and that's up and running. But that's the big companies. They put a lot of money on it. But for the small companies, certifying and being sure that what you send to your customer is qualified and is what you think it is, we're not there yet. A lot of research is happening, and we're making good steps, but yeah, it will come there. But the main thing there is collaboration. Not one person will change the world. We all need to do it together. And there, I think the AM community is aware and getting more aware that we need to do it together. And that's important also to have a good network in Europe, well, all over the world. But that's also where 3DOP, where we believe that expanding the network and having bigger collaborations will move AM forward in the next years.
Alex, sorry, I need to tackle you again on that topic. I mean, because you start with the innovations when they start being a company, basically, yeah? And you scout them and you evaluate them. And for me, a success story would be, and probably Andreas, you agree on that, the moment you start earning money. From a company perspective, not from a VC perspective. This is probably later or earlier, depending on the case, okay? So, how many of the companies you explore are coming to the point and earning money, and what are the crucial factors to get there, to be a success story?
Be as application specific as you can be. Like, we have this couple of base technologies companies also in our portfolio, but they found their application, their niche, where they said, okay, we get maybe rid of all the features that we don't need, and then we can get into also profitable margins and make money with the technology if we are able to say, hey, this is only, and then you get even like your customers pay for them and do a joint development agreement. It's even much better because you say, hey, we're really delivering your solution and we can scale this up together. So I think it's really about critical factor is, okay, be as application specific as you can be.
So
I mean, maybe to add on that, and so what RapidShape is doing is we are very application specific. For example, when you're thinking of a dental lab, a dental lab, you know, like in Europe today, there is scarcity of skilled workers.
Yeah.
Because the German Handwerk, how you call it, you know, like you're this really specialized way of working together with your hands in order to make a model, to make teeth, to make a bruxism splint or whatever. This is very hard to find people there. And actually, what is happening as a consequence? You're having huge delays in the treatment, and you're outsourcing your production to other places where you still have people who can do that job at a certain amount of
and probably
money.
Cheaper labor force.
Absolutely, there's a lot of foreign outsourcing happening, and I mean what a 3D printing technology is providing, and this is not future, this is now, this is the last 5-6 years already. I mean, the first international dental show that I've been was 2014, and in 2014, 3D printing was not even, you know, like when you talk to dental labs, what is that? Additive manufacturing? Can we make a coffee with it or no? I mean, that was really completely not in there, and today you hardly have any dental lab which has not a 3D printer.
Oh.
And they are using 3D printer every day to make a very big amount of their work. And they're insourcing more the work. And they're using, then because the technology is automated, then they're using less people, so hard to get them, in order to do the job. And then I would want to make another example for that. For example, I mean, it's about bruxism splint. I mean, Alex, just if you think of, you have one of those startups and you're thinking when the break even will come, and you're starting to grind in the night, you're like, will it happen or no? So you need probably a bruxism splint. And actually, there is a very, very high amount of people which are grinding in the night.
Yeah.
Maybe you know by yourself. But there is...
I do.
Sorry. But if I may ask a question, do you have a bike? Do you have one?
Yeah, a Beischiene.
A Beischiene.
I don't know what the English word for that.
Bruxism splint.
Ah, okay.
It's a bruxism Beischiene.
I try to remember that.
And for a bruxism splint, this Beischiene, as we say in German, a lot of patients are actually not treated for that. Why? Because you don't have pain with it in the beginning. Maybe you have a negative sleep experience, but you don't have pain. So after 5-10 years of grinding in the night, then you're coming to the dentist and you say, I have this particular problem, so give me a solution for that. But maybe before 3-4 times you have visited your doctor and you saw it, but do you want to also take care about this? No, but the other, there's so much of pain, so I'm not doing that now. So there is even treatments which are delayed because there is not an immediate solution to make it. With 3D printing, some of the dentists, they do have already a peroxisome splint maker, an additive technology that you can do it in an hour. And then they're just doing it along you're treating your caries case.
Awesome. But that brings me to the next question. I mean, this is like a real practical solution we can all imagine, right? So imagine we have reduced labor force. So, and we have, the education is not that easy because it's a very complicated handwerk, or it's super complicated to do, to perform, right? So getting into using a 3D printer isn't easy either, isn't it?
You asked before what is success, and you asked for collaborations.
Yeah.
I mean, actually, if you're just a hardware manufacturer and you're making the most best 3D printer, and it has 10,000 knobs on it, and it's very complicated to operate it, it will not work. If you don't have the design software, which automatically by a scan makes you by artificial intelligence, all these nice buzzwords that we can say now, but that makes you a design that you can print thereafter, and if this is not done in 5 minutes, then the case would not work either.
Yeah.
So you really need to bring various disciplines together to make it a success at the end.
Okay. Finally, let's talk a little bit about, let's say, technologies or target markets where we could find the success stories in the future. Because you are innovation focused, you as well are innovation focused. Alex needs to, because they earn money by innovations basically and need to be successful in the future. So what are the markets we have to look in? Today and yesterday they were all talking about aerospace, military and healthcare. That was and dental mainly was the main thing. But let's take a look into the future where we will see the big success stories. What do you think, Philip?
Listening to the discussion, I think we need to be very clear that what you're talking about. If you're talking about additive manufacturing companies whose business purpose has something to do directly with additive manufacturing, it's a whole different thing than having a user of additive manufacturing and just using it to improve their own business.
Okay.
And in the second one, there we see a lot of in very traditional companies that produce hardware, that produce machinery, that produce components that are somewhere in some technical device. And they might not be very fancy, they might not be very sexy, that might not be the big rocket engine or the heat exchanger, but these are parts that work. These are parts that create revenue, and these are parts that make better business. And these are the ones that actually I think people should focus more on.
But is there a specific market where you would say, I see the most, let's say, prospering opportunities?
What I see a lot is medium-sized companies that are the champion in their field, that have a very specific, very technically complicated product, typically in small quantities and very specific to their industry. This is where we get easily into a very profitable situation.
So Philip tackled the, let's say, the customer-focused approach. Gerd?
Yeah, I think success stories will come automatically when AM will scale, when the material costs will go down, when the machine costs will go down, when more and more people are educated on AM, because actually a lot of people still think in traditional manufacturing and I have this design, can I print it? That's not why you need an AM machine. It's combining the AM technology and having great ideas where you combine functionality into one piece, reducing the complexity, or at least having one piece with a lot of complexity which you can just print and have being used. Those will be the success stories, but for me it's difficult to tell which it will be, but there I see a lot of progress possible.
Okay, now I come back to Alex, because Alex, one of your colleagues was squeezing me when I started my business and telling the magic word, focus, focus, focus. So when I have the task to create success stories, I need to focus on specific markets. Or even if I want to scout as a VC, I need to focus on a specific topic in order to scout faster. I mean, now it's not the time to scout that much, I assume. But what are the markets you as AM Ventures are focusing on? Because you see them most promising.
I think, again, my key message is, okay, don't see additive manufacturing isolated. See it as a key pillar within advanced manufacturing. And there's a big trend coming. Okay, we have to, software has not eaten the world. Unfortunately, yet. And I think there's still, even if we talked about dental, there's so many advancements in new materials where you suddenly, which unlocks new applications in the end. So there's still a big improvement, even I think in the dental space. Customized healthcare solutions, what we have seen with the orthodontic industry, with the aligners. Everyone is chasing for the aligners, and we want to bring it into serial production. But I think medical in general is a big space, and we see it with 3D Systems, right? They're a really focused approach on the medical space. So I would go for medical, because I'm also personally wise, like, I think that's most fascinating to see the impact of customization. And having like a bigger impact for the patient, and to shorten treatment plans and have better quality for the patient in the end.
It's interesting that you mentioned medicine, or you've chosen medicine or healthcare in total. I would totally agree. My only issue there would, if we're talking about business cases, and that was the title of the panel, then it's the hardest to achieve it there, because we have this long regulation and certification times until we get this solution into place, right?
Then look for a patient capital investor.
Okay, very good.
But yeah, I mean, you have these highly regulated markets, but there are some other applications that maybe need less clearance and are not FDA cleared, where you don't have the skin contact. So there's a huge bandwidth of still application also within the healthcare industry.
There is another industry, which is magnetic materials, which are printable, and we are looking for applications. With electric vehicles are a potential candidate where printed magnets can, because of the freedom of design, you can make huge benefits, which might potentially have a breakthrough in the coming years.
Oh, well, then it's interesting. Now we have to look again for an application where to use it. Yeah? And there's what would be your choice?
I mean,
I already have done the choice, right?
I have a company which is 80% active in medical.
Yeah, okay, sorry for that.
Actually, what regarding the certification aspect that you mentioned, the nice thing is that we are so many. There are so many humans around, isn't it? So that means when you are making a certification for a certain application, there is quite a high number normally of very similar, not same but similar, right? And this same but similar, not same but similar, this is actually also one thing which can bring success. And I also believe very much that in the medical space, a lot of things can happen in future in addition by making things more easy, more accessible, having people, users, able to use the technology, not only the equipment, but the technology in a more simpler way. But I think that there is also, outside of medical, there is spaces. I mean, let's think of Adidas and their printed shoes or soles. I mean, what they made before. I mean, this was huge. Now we can think of
whether it was a success or not.
Yeah,
I'm not sure on that.
Yeah, but think of the trend that has been created.
Yeah.
Think of the turnover which was created in the background. And think of all the different things that you are seeing now coming up as a consequence from that.
Yeah.
And at the end, it depends. So it can be also technical for sure. It must not need be medical, but I think that in medical there will be most of the indications in the very near future.
Okay, thank you so much. Guy, thank you. I mean, what was fascinating to me was to give you feedback on that topic, because I was only the host. Yeah? I have only a little bit of input. It was super interesting to see the different perspectives, to be honest. I mean, we haven't mentioned that many success stories, and this gives me the feeling that it's still difficult to define what is a success story. That's the first thing. I don't think we have that few. Mm-hmm. It's just difficult to really define what can I mention here on that topic. But I mean, I'm really appreciating feeling that we brought this knowledge together. So many new impressions, new insights for me in order to evaluate things that I'm seeing right now. That was amazing, to be honest. Thank you for that. Yeah. Okay. That was our panel. Business cases and success stories. Thank you so much, guys. Enjoy the fair. The most important thing is have a lot of success here at Formnext. That would be my wish to you. So, ladies and gentlemen, we're doing a short break and then we are wrapping up the day and the first 2 days of Formnext in our after-work talk. See you in a few minutes, and thank you to you, and see you right soon in 2 minutes. Okay? Thank you.
In my job, the slightest change of weight makes a difference. At Formnext, I get to work shoulder to shoulder with the AM community and push the boundaries of possibilities. Solutions presented at Formnext for materials or production systems become increasingly effective year by year.
Designing geometrically complex components and finding solutions for specialized functions, isn't it fascinating? The exciting thing about 3D printing is, if you can design it in the software, you can produce it. The exhibitors at Formnext demonstrate such groundbreaking feats.
My purpose, making not just series production, but also making customization affordable, be it for prototypes, spare parts, or mass customization. This is where additive manufacturing gives you a competitive edge.
The whole world is talking about the need to rebuild supply chains. But many of my human colleagues overlook the fact that conventional manufacturing technology won't cut it. Distributed manufacturing needs a digital manufacturing method, like 3D printing. So me and my colleagues are an important part of the AM community.
This is what brings me to Formnext, my quest for industrially viable solutions.
The era of design freedom and innovation has now arrived in industrial production.
Simply put, AM celebrates sustainability.
Artists that specialise in 3D. Yes, it's possible here at Suto's booth. Let's have a look.
We are artists that are using 3D as a tool since a few years, and we love it. We fell in love and we deep dived into it.
I wonder how they choose their motors when designing for the 3D printer.
Since we are artists, we always create concepts for series, and in combination with the 3D printing, it's always for us important that we have like a message that we transport through the art.
I wonder if there are any restrictions in terms of shape and size for 3D printing in art. Or maybe it's only in my brain.
No, not really, and we always try to get a little further there. So we have our own print workshop with SLA printers, FDM printers. We have upcycled filament makers and shredders, so we can create our own filament, and we also do cooperations with other concerns here from the fair, for example, Builder Extreme or Photocentric, where we create big showpieces and make cooperations and cross-communication projects.
I wonder if 3D printing is the way to enlightenment.
Hello, ladies and gentlemen. Welcome back here at the industry stage on the Formnext in 2024. I'm totally confused today. So we want to make a wrap up of day 2, or pretty much of the first 2 days in our after work talk. And in order to do so, because Frank, I first greet Frank. Frank, good to have you back here on stage. And I tell you what,
it's always a pleasure to be with you.
I tell the three of you why it's so important that you're here, because Frank, the two of us never get on the fair, right?
Yeah.
We can't experience anything. This is why we invited you. So let's start here. I don't need to introduce you, but it's Tuan Tranfam. You are president for the regions America and Asia Pacific at Anisoprint. Is that correct?
Anisoprint.
Yeah. But honestly, as you are so active on social media, nobody needs to introduce you. A pleasure to have you here. So we have Joris or Joris. Yeah. What do you like?
Whatever, it's okay.
Yeah, Joris Spears. You are vice president of consulting at Additive Manufacturing Research and executive editor at 3dprint.com. So you can tell us a lot. And last but not least, and we know already each other, it's Matthias Schmidler. You are managing partner at AM Power, and you're delivering some very insightful information. Matthias, I think you made it on time, but I think you're really busy at Formnext, right?
I think we all are, but yeah. Formnext is busy, great, and also stressful, to be honest with.
Yeah. So what is the kind of stress you have?
Just
let us know.
I mean, I think the stress comes from not being used to talk the whole day.
What?
Starting from the morning through the whole day.
So usually
we have the same problem.
I mean, usually with work, right? I mean, usually I'm sitting on my desk and I'm working, or I'm talking on the phone and something. It's different if you in a hall with dry air and everything. So it is exhausting.
But tell us about your projects. What are the content of the many talks here?
I mean, we all know that this industry going through change right now.
Yeah.
I think hockey sticks are over, and we are all looking into how to become profitable, right? How to make money with 3D printing. I think there's a podcast somewhere, making money or printing money, right?
Yeah.
That's
I don't know.
hitting it pretty good. Making money with 3D printing is the big question, and that's what everyone is wondering. I mean, first of all, the customers, the users have to make money with printing. They don't do that for fun. Most of them actually try to create great products, and that generate revenues, that generate income, etc., etc. And secondly, all the companies who supply into this industry who now lack the investments because it's much more difficult to get any funding in this market right now. They need to become profitable, or they will vanish from this market. Yeah. And that's the situation we are also in right now, also ourselves, by being approached by companies who are looking for funding, being approached by companies who want to merge or want to explore opportunities on the market.
You have an own booth here?
We have our booth, we have our booth in 12.0. Don't ask me for the number, B something, I don't know. But it's green and blue, so you'll find it.
That's a good hint. There was one question to you. I mean, let's say on Saturday morning, when I getting relaxed after the 4 days of Formnext, I will visit your website and try to summarize what I missed, basically. So give us a summary of the first 2 days. What will be the headlines on 3dprint.com for the first 2 days?
Yeah, I think, more realism and more application focus. Yeah. So we're seeing this before. Like before, it was the box people, the really were doing things. Here's our box. Give it €1 million. Take 3 years, spend 2 million more, and then you can have this amazing technology for aerospace. And now it's much more people are doing an application focus because they want to make it easier to sell things, or they're doing services to make it easier to sell things, or they're just getting everything together and saying, okay, you come to us and we give you a part. And so the value is really in being able to very, very quickly get a customer at very little risk to them. You're not going to risk your career anymore. You're not going to risk your a lot of money. You're just going to buy a filter.
Yeah.
For a filter light, you're going to buy a one bike seat kind of proof of concept, right? So it's much faster. So there's much more realism. Totally agree. There's less money. We can't be frivolous anymore, and we have to actually like get to the applications that make sense. That aren't cool anymore. One of the great examples is I've seen a lot of parts that look really boring. Like before, it was all these aero spike engines and everything looked like Geiger made it and it was all sci-fi and stuff. Now it's like, this is a pipe fit thing, and it's like boring as hell, dude. But it's like, okay, that excites me now.
Matthias, I don't know whether you remember at AM Forum, that was one of the best quotes from the whole forum. That somebody said, "We need to get boring again."
Yeah.
That was I love that so much.
Manufacturing is boring.
I mean, it is boring, and it should end up in a rut. What were your highlights over the last 2 days? And do you agree with the two guys? If not, please be open.
I do agree that there's much more application focus. It's just good to be back. I think it's like the annual pilgrimage reunion, meeting the right people, making new friends. I think this is a great format and see newer technology, but there's a lot of the same stuff. And what I worry about, to be honest, when I look around, this is bigger than last year, 860 exhibitors, but I'm like, is the market big enough to feed all these exhibitors? And I'm getting worried. Yeah. Because if you're not different and unique and you identify a few killer applications, you're not going to get money. You're not going to survive. You don't deserve to live. Mm-hmm. So all the free money we saw, $2 billion a few years ago, money is dried up. So the few companies that actually are able to get money, those are real companies.
Yeah. And also I think what's interesting, I think we did some research, like one of the funniest things ever is like the biggest funding body in 3D printing right now. The biggest thing in the entire industry is the Air Force Research Lab, right? In the US, Air Force Research Lab is putting in more money than any other organization. Oh. And the US military and defense establishment is by far the biggest funding, above private equity, VC funding, everything. And the fastest growing application in 3D printing at the moment is suppressors for weapons.
Yeah.
So we're talking about a metal 3D printed suppressor that is meant to reduce the signature, the heat signature and the sound of a gun. Right? And this is something we did a report on this in 2017. We do another one this year, and it's exploding. And like literally, the service bureaus are full of suppressors. So all of a sudden, we started a couple of years ago. When we started, it was all like, heal the world, and when you make life a better place. And now it's like, wait, we're making suppressors for guns.
Joris, when you compare the revenue in total with different industry sectors like medicine, automotive, and so, how is it compared to them? You mentioned it is fast growing, but how is the actual
It depends
size?
where you. I wouldn't be able to say that right now because it's very difficult.
Because we had a discussion this morning, and I quoted something similar to what you said without that example, and I was folded behind, by some guys here on stage. They said, okay, defense is important, but nothing compared to medicine, for example.
It depends what you conquer. The money flowing in is much more from defense than for other things. But the applications like Invisalign plus all this other stuff is, of course, in total more than everything that's happened.
Okay.
We would expect to, if we fast forward a couple of years, this picture to be remarkably different.
Okay.
But at the moment, I can't say the revenue-wise, it is indeed. I agree with, it is smaller than other more established segments. But the cash coming in and the number of service bureaus and the number of machines going to that business, as compared to a couple of years ago, is a staggering difference.
Okay.
I think in some way it's follow the money, right?
Yeah.
In some way, you can say that 3D printing industry, the honeymoon is over, the party is over, the money has been depleted. So now wherever the money is coming from, it's going to dictate the new direction of the industry. So to honestly, in my opinion, the industry is like, what got you here won't get you there. And if you don't adapt and solve real problem, you're not gonna be surviving in the coming years. So this is a wake-up call.
Yeah, but honestly, in my opinion, that's what I mentioned this morning, right? I mean, and I'm fully behind this opinion. I think this is a good moment, to be honest, because as you said, if you don't get a solution that makes money, you don't deserve surviving. And like we discussed it yesterday with Arno as well, so water and the rivers running low. My wife is always laughing about this quote. But what is meant is that you can see the opticals, you need to get better in navigating, and you need to get through the river with lower resources. That's basically it. And this will differ the real success stories from the ones that had been holding up by money the last few years. So, Matthias, one question to you, because, I mean, you are supplying us the AM Power report, which I'm really looking forward next year. So, what are you thinking about next year? Is it getting more difficult to create the report? Because, I mean, there was so much changes in 24, right?
Yeah, there was a lot of changes. And actually, the difficult part is to identify the companies that are not on the market anymore, because that's not being published anywhere, right? So they're just secretly vanishing from the landscape, so it's kind of difficult to track that from time to time. On the other hand, we see also that the companies who are actually growing and who mean additive series and who are profitable, they have a big interest in numbers, and so they are also open to provide the numbers because they see the need for market intelligence. Mainly because it's not so much about growth rates anymore, but it's getting more and more about the cake and how the cake is distributed among the leading players. So usually at a consolidated industry after such a phase looks like in a way where you have 5-6 players who dominate maybe 70-80% of the market, and then you have a bunch of players who look at certain niche markets and serve those niche markets, and that's where we're going to be in I don't know, 1 year, 2 years time. And the large players are the ones who are interested in those market numbers, and so I don't see more difficulties. Where I do see difficulties is the whole political situation, right? Yeah. I mean, I think between Europe and the US, I still see no problem, but there's so much happening in Asia that we don't see and we don't necessarily see all the time. And you talked about the biggest funding being from the defense segment. I'm pretty confident that the same is happening in China. And I mean, obviously, what is financing those companies there is also predominantly aerospace and defense. But it's much more difficult to get actually substantial data on those programs because obviously they don't like to share much about that. So I think that's the blind spot that everyone is working with in the Western Hemisphere. And we're trying to dig into that. We're trying to bring light to it for market intelligence side. At the same time, trying to maintain a confidential relationship with all those players because it's a lot about confidence and confidentiality, and at the same time publishing numbers. It's a difficult task
I believe
that's the difficult part of actually doing a report in that times. Yeah.
Just one question, then I hand over to Frank again, Duan. I mean, let me tell it from my perspective. So you sit here and you talk to the people all over the day and you get different impressions. And for example, I've seen yesterday the startups. So Matthias mentioned, and I totally believe that, you see a consolidation right now. So there will be dominant players surviving and you have these niche players. Yep. That would lead, in my opinion, to some certain orientation or focus in the companies presenting to you. But I don't see that. You know what I mean? So I see still the same amount of fancy ideas and directions that people are running. And usually, from my perspective of a consolidation, there should be like, I'm focusing only on these 3 markets right now, because, and I don't see that. Why is that? Or how do you see that?
Well, the key word is there's a huge regrouping right now. While the consolidation attempts last year failed, it's happening now, but it hasn't commenced yet. So for instance, Leonardo mentioned wants to buy Tesla Meta and Markforged. God knows how they're going to integrate these two companies, the people, the talent, the R&D, let alone the resellers, and how that will impact the rest of the industry. So I think it's yet to see, but definitely this regrouping, everybody needs to see that there will be fewer gorillas. And if you're chimpanzee and you're not focused and you're unique, you're going to be eaten alive. But you need to go to a different island. Did that kind of answer your question?
I love that. I love that explanation. Thanks so much.
Can I add something to that? I mean, to your question, why don't you see them? Honestly, because I think they're not at Formnext.
Yeah.
The companies who are actually focusing on a specific segment, they don't see their customers here. So the ones who are really looking into, let's say, dental, let's say orthopedics, or let's say defense, space, whatever. The company who's really focusing on a specific solution for a specific problem doesn't find its customers at Formnext. So I think what we still see here are all the players who play in several industry segments and who still are open to many segments, many applications. Right.
Okay.
So and there's a talk a lot already around the whole industry about where do we exhibit, where do we find our customers. And I think the ones who actually try to focus on specific segments are probably better off actually meeting their customers at where they are, right, and where they go.
For example. Yeah, very good answer.
I wanted to hook on the aspect of funding. Matthias just gave the impression that there is happening a lot. You saw it from the perspective that you miss a data, that you do not see what's happening, but that what you meant, or what I heard, is there is happening a lot. And my question is, do we have a message here for our government that should happen here more? Can you make a vote for our government in Germany or in Europe that there should be funding programs or more support, something like that?
Definitely. Yeah. I mean, exactly the way you see it. I mean, the US is pushing with applications. China is pushing with application. Every smaller country is having similar, more focused maybe programs. And to be honest, in Europe, we are missing the support to actually invest, supporting companies by investing into new applications that are better made with additive, right? Maybe not even necessary additive, but rethinking applications and rethinking manufacturing for certain applications. And we know the obvious industries where this makes sense. It's medical, it's energy, it's defense. And there are so many benefits that you can draw from it. From the one side, you can increase performance, you can reduce CO2 footprint, all the things that you're actually aiming at as a European governmental organization. All those things can be supported by additive manufacturing. And I'm not a fan of directly supporting additive manufacturing companies.
I think we cannot do that in Europe, like in China. You can give 1 billion of
you might find
company,
ways.
but
You might find any ways to do that if you agree on the European basis, probably. But in the end, I think there's much more value in supporting companies adopting that technology, and there are possibilities to fund that. It just needs to be done. And we know in Germany we have this painful instrument of blocking any credit that you can take as a whole country, which is basically stopping any innovation to happen in that segment and stopping the government to actually fund investing into manufacturing technologies.
I don't think it would be very useful. We just need to make better printers. We need to make better products. We need to be better engineers and better inventors.
Oh, and how to get them?
No, but see, the thing is, the biggest company in additive manufacturing in terms of revenue, do you know what it is? Anybody want to guess? It's Bamboo Lab. Bamboo Lab is the biggest company in additive manufacturing in terms of revenue, and it may have $1 billion in revenue. We don't know yet for sure, but I think it's approaching $1 billion. So it's much larger than 3D Systems and Stratasys. And it's, 3 years old, 4 years old?
And they started with Kickstarter, wasn't it?
Yeah, they started with Kickstarter and VC funding, right? A lot of VC funding, but they made a better printer. They made a better printer than all these other guys who have been making printers for 20, 30 years. So it's like, it's not about that. It's about like having the skills to make a much better device that changes the market. Yeah. And this changes the market, right? Yeah. I mean, I know people that are making 800,000 parts on Bamboo Lab printers, and it yields above 90% on a $1,000 consumer device. right? That changes the market. And I think the problem with this like subsidy stuff is it always goes to, in Europe, it'll go to like, oh yeah, we're going to recycle something or something. It's always useless, right? And the problem is it's great. I know people live off of this stuff, but it's not going to get us something that will rival the Bamboo Lab. You have to be more ambitious than these guys, and you have to make a better device. And I think that's the thing is like we're used to being the technology leader because historically that's what Europe has been in place, a technology leader. We have to accept we are not, and we have to figure out how to make ourselves the technology leader again. And that is, I think, a much more different approach. We have to dream bigger, and we have to actually make that work.
But the problem is we are in a situation where money is not available anymore.
Yeah.
Or much more difficult to get. So you can only become technology leader if you have the customers who push you, if the customers who have the money to actually invest into you, and if you have profitability in eyesight somewhere. And that's where we are right now, I think. So
I actually have a different take on that. Even with the government support, even there's a renewed influx of money. If you go back to the Bamboo Lab example, I will redirect the focus to talent. We are very much the very same people, but we're not reinventing ourselves or thinking differently. My interpretation of decoding Bamboo Lab is the talent. They came from outside this industry. They took software, machine learning, user experience. They took a fresh take. You know, I've been in 3D printing for 21 years. When I hear other Americans on the Zoom call say they love their bamboo, it's like, shit. You love a product? This sounds a little bit like Apple, right? Then you deserve to make money.
Yes.
And so that's like a wake-up call for the industry. It's like, you forget making a printer. Making a printer that people actually want to use. Yes.
Yeah, or, I mean, and probably understood Matthias correctly, if you look in the US market, what I often see with startups especially, they get really quickly orders by NASA or by the Air Force, they integrate them, and that would be a healthy investment, you know? It's not like getting money for nothing, they're getting money for a solution, and that would push two things. First, you get technologically more developed again, because you have to think of how to provide a solution, and you get money without getting investments. This should be, because you are financing yourself in an organic growth by delivering solutions. That would be, in my opinion, the way.
But coming back to my initial question, what can our message be to the government? Okay, we have the one aspect of money or of funding in certain ways, and now we have talent. Could it be to strengthen the community by bringing the knowledge into the young people, into the schools, into the universities? Is funding new institutes for building up a knowledge community? Would that be a message from us here to the deciders outside?
I personally don't. Well, you want to?
I think money will come if you have the right vision. I think the biggest problem is several governments do not have the right vision. If the future, where we're going, is the fourth industrial revolution, if the future is factory of the future, automation, if the future is an integration beyond 3D printing or IoT, machine learning, sensors, if all that is the future, like NVIDIA CEO went to Denmark to initiate the new supercomputer print farm in Denmark. It's like, that's an example of a Danish government pushing for the future. If you don't invest in the future, you're not going to help manufacturing, reshoring, or anything. So I think it's a leadership problem, to answer your question with the German government. You need the vision, and then you get the support and the funding to follow through. If you don't have the right idea, you shouldn't get funding.
Yeah. No, I think so too. But there's also a trap in this. I like the Air Force example, because in the US now they're doing attritable drones, which is a word I still don't know how to pronounce, but it really means it's a drone that's disposable but also costs $100,000, right? In Ukraine, their drones are costing $180, the FPV drones, right? And there's thousands of Creality printers and Bamboo Lab printers making them. There's also some MGF. There's EOS as well, which they probably weren't happy with, but whatever. This is determining the future of this warfare thing. The future of the warfare is not to make the drone the Air Force wants, it's to make the drone that makes the drone the Air Force wants obsolete.
Yeah.
So if you're looking at that, how fast this is changing, we're talking about an application that is like something that is overtaking. They're making maybe over 3 million 3D printed drones this year, and many 10 million next year. So it's one of the most 3D printed parts in the world is a drone body, right? But they're only doing this because they're faster. And they used to print the whole body, and now they're doing laser cutting it because it's cheaper.
Yeah.
Right? So it's like we're a useful technology, but we're a useful technology to usher in technological change. But that only works with this vision idea, and if ultimately the device is much better to replace everything else. So we're technologically being disrupted in a certain sense, and that to me is really exciting, that we're able to now have the machine and the part cost down to a level where we can actually disrupt things. We've always had the problem that cars don't work, right? Because a car, it costs about 20 euros per kilo, right? If you look at like a Toyota Corolla, Golf, you know? And then we're talking to these guys, and it's always like, it's too expensive. Of course it's too expensive. And then bicycles work, because a racing bicycle it's like 1,000 euros per kilo. So we only got the really expensive stuff. And now I think really what's interesting is now we're getting cheaper, DED, you know, it's cheaper machines, things like Meltio, stuff like this. And we're talking about much cheaper per kilo, and then we can disrupt more things. So then I think we're actually going to be in a position that if you do want to talk to the government, say, okay, we can really change how we make a chassis, or we can change how we make a thing, rather than doing only the fancy satellites, right? Or you know, rocket engines, stuff like this.
So no time is running out, or was running out already. But still, let us take 1 minute for the audience to hear from each and every one of you, and take 10 seconds to think about it. What was the most amazing thing you have seen here at Formnext? Because honestly, the three of you are so well connected. We want to hear that for sure. Go on.
Ooh, okay.
You go first.
Okay,
Yeah.
Schaeffler, the Schaeffler machine. I love it very much. Multi-material, 3 different materials on the machine at the same time. Better heat sinks, better mold release. I love it to death. We know already the technology's been around, but this is actually there. You can buy it. And I think it's going to change a lot of stuff in electronics and stuff. I love it. Love it.
Cool. Matthias, already something, beside the many conversations you had?
There's something coming to my mind. I'm certain I'm going to see more for the next days. But what I thought was a really great thing was AIM3D. I don't know if you know the company. It's a small FDM, pellet FDM company. They've developed a slicing tool that allows, they call it voxel fill, that allows them to solve the problem with the Z strength in FDM.
Yeah.
It's a major problem that's hindering a bunch of applications to become real, because you can always break the part in one direction. It's not isotropic strength in those parts. And with their software, they can actually transform every 3D printer by just changing the slicer software into actually having isotropic properties, nearly isotropic properties in Z strength in all 3 dimensions. And I think this is a very small thing. This is a very small key thing, but it's going to change. It probably going to change a lot of use cases in FDM that we don't even know yet.
Great.
I think to my point is, to Joy's point, a lot of technology become more affordable, more simplified, but I think what I still enjoy the most here at Formnext is the conversation that happened randomly. It's like I was in the Anisoprint booth with just talking to a prospect, and Scott Crump, the grandfather, the founder of FDM, of 3D printing, stopped by and he wanted to chat with us. So I think the conversation that we hear, we learn from having conversation around randomly, that makes us think more differently. I think those are most valuable to me, is the conversation through the networking.
That's the best closing word we could have, Tuan. Thank you so much for that. Thank you for being our guest in our panel. Thank you, fantastic. Dear audience, thank you so much for joining us on day 2 at Formnext 2024. And as you can be assured, we will be here tomorrow again. So please check on LinkedIn in order to be on time for our live stream. We will start tomorrow with our morning talk and introduce you into the day. It was a fantastic second day, and I'm really glad to see you tomorrow again. Bye-bye. Have a great evening.
Let's take it real slow.